So, good afternoon to everybody. Welcome to International Symposium on Biosecurity Measures in Beekeeping. Firstly, I would like to greet you all warmly in front of the Federation of Veterinarians in Europe. My name is Ivana, and today I will try to lead you through the agenda of this symposium. So here are prepared a very interesting presentations regarding the biosecurity measures, which are important part of successful apiary management, but also the public health, so the protection of the bees, human and environmental health under the One Health approach. So this symposium is organized in the collaboration of the Istituto Zooprofilattico Sperimentale della Lazio in the Regio e Toscana, then the FAO Reference Center of Apiculture, Health and Biosecurity, and OIE Collaborating Center of Beekeeping Management Practices and Biosecurity Measures in the apiculture sector. Firstly, I will invite the representatives of the authorities to give the welcome talks to the participants. So firstly, I invite Dr. Andrea Leto. He is General Director of the IZSLT Institute in Toscana. That is the FAO Reference Center for Apiculture, Health and Biosecurity. And that is the OIE Collaborating Center for Good Beekeeping Management Practices and Biosecurity Measures in the apiculture sector. So, Dr. Andrea Leto.
Sorry. Dear participant to this international webinar meeting, it is really a pleasure for my institute to host today so many experts representing the different continents as well as international organizations. We wanted to organize this event to celebrate our first anniversary of the nomination as World Organization for Animal Health Collaborating Center. I take this opportunity to thank the World Organization for Animal Health for co-financing this event today, funding some of the experts. We know that there are over 20,000 species of bees, social and wild pollinators in the world. Honeybee alone pollinate 80% of flowering plants and more than 90% of the leading global crop types, increasing quality and quantity of the productions, providing a global value of $217 billion. Bees are indeed not only honey, but have a much higher value for the globe, and we do not have only our western honeybee. Together with wild pollinators and social bee play a major role in maintaining biodiversity, ensuring the survival and reproduction of many plants, ensuring forest and environment regeneration, sustainability and adaptation to climate change, and improving the quality of agricultural production system. In this webinar, we try to cover the measures applied all over the globe to prevent and control the diseases of the main kind of bee that are kept. Bees and beekeepers together can thereby make a vital contribution to the attainment of the Sustainable Development Goals, age no poverty, zero hunger, sustainability cities, life on land. One special thank to Food and Agriculture Organization for participating today by its headquarters in Rome and by the Arabian Peninsula. Our institute is for this organization reference center for bee health and food security since 2020, and we are glad to collaborate on the topic of sustainable beekeeping and on the effort to prevent the antimicrobial resistance in the One Health approach. Finally, I have to tell you that our institute is glad to be a member of Apimondia, strengthening our active collaboration with the beekeepers from all the world. Putting together researchers and producers is a win-win strategy. We share the activities, working fruitful together in several activities and in an international project. The last of is the Horizon Europe Bee thematic network, which will start on the 1st of September of this year. I thank for your attention and I wish you a useful webinar. Peace and food in the world. Thank you.
Thank you very much for your presentation and welcome speech. And the next one, I will invite Dr. Andrea Maroni Ponti. He is a veterinarian of the General Directorate of Animal Health of the Italian Ministry of Health. Since 1997, he has been dealing with plans for eradication and surveillance of the main animal diseases. And since 2012, he has been also involved in the management of diseases in the beekeeping sector, with particular regard to the surveillance and eradication measures of Aethina tumida in Italy.
Okay, thank you very much for your presentation. And I thank you, all the organizers, for inviting me for this. I just give a very short presentation of what is our plan. The Ministry of Health of Italy want to plan for the next future concerning bee disease and in particular biosecurity. So I just give a short presentation. I don't know if you can see. Could you see? Yes. Hello? Huh? Così? Could you hear that? Could you saw my presentation before? No?
No, Andrea, we cannot see, but let's do that after the other greetings. Do you agree?
Okay. So, okay. But anyway, I just start okay, the presentation, but just want to give my greetings for this symposium. And really we think that is very interesting, is a move forward to the manage of the bee disease. So we think that this topic could be very, very interesting and as a key point for the managing of the prevention of the bee disease. And the Ministry of Health of Italy is very interested about this topic, and we want for the future give very a lot of importance for this subject. And I just want to share with you what is our future plan for concerning biosecurity and the use of best practices in beekeeping sector. Okay. Cos'è questa prova? No. Questo. Could you see the presentation?
Yes.
Okay. Sorry, but so just to say the truth, that in Italy the beekeeping sector was not really considered a priority. This has been for a long time, especially for the veterinary service, which were not very committed to dealing with the bee disease. In fact, the sector was under control of other people, like technician, but the veterinarians were not really involved. The situation has been changed from 2000 because with the start of the problem with the use of drugs against varroa, so we decided to work on this problem with more attention, especially we saw the use of drugs and veterinary medical products which were not very used in a correct way. And this situation put in evidence that the veterinary service were not very prepared to deal with the bee disease and to the entire problem of the beekeeping sector. The situation was also put under light when we had an incursion of Tina tumida in 2014. And so we acknowledge that the whole veterinary system was not really well prepared to tackle this kind of problem. And I think a very key point, a very important point was in April 2016, the issue of the new regulation of concerning animal health law 2016-429, which also applied to bees and bumblebees. And this was a turning point for our public administration to deal with the beekeeping problems. So in this respect, we have a pathway that we want to follow to enhance the capacity building of the entire sector. And so we have different points that we want to follow. The first one is the compulsory training of beekeepers will be compulsory for all the beekeepers that should have a certificate concerning the bee disease. And this training will be focused also on biosecurity and best practice, because we think that these two means can help really to prevent the introduction of disease in the apiaries. The second key point is the veterinarians. Beekeepers, they should rely on vets that they will give advice on biosecurity and prevention, so not only animal health visit, but also advising on these two topics. And at the same time, the clinical inspection will be performed on risk-based. So we think that in this case, veterinarians will go into the system in a very huge and very important way. So as you know, as the definition of biosecurity, biosecurity are all the management measures that designed to reduce to manage the introduction, the development and spread of disease in animal population in establishment. This is the definition of biosecurity and regulation 429. And so concerning the biosecurity, we want to apply biosecurity and best practice measure, of course, based on risk-based. So we are still in a process to define the criteria, how to apply this biosecurity measure. Of course, the criteria like movements consigned, number of hives, the situation, epidemiological situation in the zone. And then our intention is to use the official vets. In Italy, we have more or less 2,500 vets working in the animal health. And part of them, they will control the level of application biosecurity by beekeepers. And all these outcomes of this control, they will put in a new system that we probably from 2024 will be applied also in beekeeping sector. It's called Classifar, which will help us to rate the level of risk of each apiary. And then, of course, as decided by other regulation, this official control will be, of course, reoriented on the basis of the risk rating of each apiary. So this is more or less what we are going to do, and we think this our plan. I think will enhance the prevention of the entire beekeeping sector. So this so the conclusion. We think that the beekeeping sector deserves the same attention of other livestock production. In Italy, it's very important to do the production of live bees and also honey products. So beekeepers should be compulsory trained on bee disease and biosecurity. Beekeepers should rely on private vets for notification, advice on biosecurity and best practice. And we for sure will rely on official control to put in place on the apiaries to rate the level of risk and enhance the efficacy of the controls. So I thank you very much for your attention, and thanks again.
Okay, thank you very much for your presentation. So currently we heard the first of the presentation in the program, and now we will proceed just with the greetings talks. So now I'm inviting Dr. Franco Mutinelli. He is a veterinarian with expertise in animal pathology, in charge of the Italian National Reference Laboratory for the honeybee health, assigned to the State Veterinary Institute in Venice. So, Franco.
Good afternoon. Thank you, Professor Geiger. Ladies and gentlemen, dear colleagues, it's a pleasure to take part in this webinar dedicated to biosecurity measures applied or applicable to apiculture industry. And I'm in charge of the National Reference Laboratory for Honeybee Health in Italy, and of course we are collaborating with the competent authorities also about this specific aspect of honeybee diseases prevention and control. As already mentioned, we learn a lot from other farmed animal species industries like poultry or swine or cattle about biosecurity. And of course, we should try, for what concerns the apiculture sector, we should try to take advantage of the experience gained in other sectors in order to improve the knowledge about biosecurity and also in order to properly apply the concept of biosecurity to beekeeping industry. And of course, this can be done with the collaboration of the different institutions and competent authorities in the different countries, of course. And we should try to raise the awareness of beekeepers and of the beekeeping sector about the need for biosecurity measures and the need for a proper application of them to the entire sector. Again, thank you very much for the invitation, and I wish you a successful webinar on biosecurity in apiculture. Thank you.
Thank you very much. So now we can proceed with greetings, and I can invite Dr. Francois Diaz. It is a scientific coordinator of Bee Health and Wildlife of the World Organization of Animal Health, Preparedness and Resilience Department. Dr. Diaz?
Yes, thank you very much. I'm going to present you so the activities of the World Organization for Animal Health related to honeybees. So I'm going to start. So can you see? Yes, can you see the PowerPoint?
Yes, but now we will just have the greeting talks and later presentations.
Okay, so it's not yet the presentation.
Yes, just the greetings.
Okay. Okay. So so I stop. So thank you. Yes, thank you for this opportunity. We are grateful to support this symposium on the biosecurity measure for beekeepers. It's the bees, honeybees are a topic of interest for the World Organization for Animal Health, and so we are very happy to have this symposium and to learn more about the biosecurity measure that can be applied for all the honeybees worldwide. So thank you very much, and I wish you a very interesting symposium. Thank you.
Okay, thank you very much. So see you a few minutes later
with
your presentations. Okay, so the next one, I invite Dr. Yungxia Song from FIO, Senior Animal Health Officer in the Food and Agriculture Organization of the United Nations. Is working for the joint FIO and WHO Center for Zoonotic Disease and Antimicrobial Resistance. So she is FIO Antimicrobial Resistance Focal Point and Unit Head, leading the implementation of FIO Action Plan on AMR, coordinating the activities with internal and external partners, significantly contributing to the quadripartite collaboration on antimicrobial resistance.
Thank you. So can you hear me?
Yes, we hear you. You can start.
Okay. Yeah, dear colleagues, friends, and participants, thank you for inviting FAO to contribute this important discussion on biosecurity measures and beekeeping in such a broad context of international experts. And in the realm of bee health, which is closely connected to biodiversity, food security, FAO is working to raise awareness of honeybee diseases and promote good beekeeping practices. Responsible use of antimicrobials in beekeeping is essential to ensure food safety concerning antimicrobial residues in hive products and safeguarding antimicrobials as life-saving medicine, both for human and animal health, with a One Health approach. In 2021, FAO, in collaboration with IZSLT, published the guideline Responsible Use of Antimicrobials in Beekeeping, aiming to raise knowledge on primary honeybee diseases and promote preventive measures for the proper use of antimicrobials. Adopting FAO's long-standing approach of progressive control pathway, which assists countries in controlling animal disease using stepwise method. FAO is also developing the progressive management pathway to reach sustainable apiculture in collaboration with IZSLT. Also, FAO is making a great effort to deploy a global survey worldwide to monitor the knowledge and awareness of good beekeeping practices and biosecurity measures for the primary honeybee diseases and understand the risk associated with AMR and beekeeping. The previous survey was distributed among beekeepers between 2019 and 2020. The answers collected mainly from EU and from North America. There are some interesting results. For example, frequent antimicrobials being obtained online without prescription, hindering the complete traceability of antimicrobials. There's insufficient awareness of antimicrobial resistance and the risk of residues. So continuous training and program are really very important. So this year, even with the support of Apimondia, we will disseminate the second round of global survey monitoring the progress since the last one in 2019. This time we will try to reach a much wider catchment area. Lastly, I would like to highlight that AMR is a global threat to sustainable agri-food systems, including honeybee production. FAO, together with partners, will ensure a coordinated One Health approach to combat AMR at all levels, including global, regional, and country levels. So with that, I wish the meeting will be a cornerstone to building a global network towards sustainable beekeeping and the responsible use of antimicrobials. Thank you very much for your attention.
Thank you very much. Now we have one more greeting talk. So I will invite right now Dr. Jeff Pettis. He is a scientist and beekeeper with over 35 years of research experience, and he currently serves as president of the Apimondia, the International Federation of Beekeepers Associations. So the Apimondia works to promote sustainable beekeeping and bees worldwide. So Dr. Pettis.
Yes, thank you, Ivana. Thank you very much, and it's a pleasure to be with you. I'd like to thank all the, especially the European veterinarians, but anyone tuning in today to this important topic. I'd also like to thank OIE and Francois Diaz for helping to sponsor it, along with Giovanni Formato from the Institute in Italy, and along with FAO and all the speakers who come after this. So again, it's an important topic that we're discussing today, and I'd like to just touch on a couple of things that some that have already been said, but a few things that I think they're important about honeybees, because we as Apimondia, we work for all beekeepers around the globe, but we also work for all pollinators around the globe, just everything revolving around pollination. Honeybees require no land to manage, and they have very little startup costs. So they're very good for alleviating poverty. And I think that's something we need to keep in mind, especially in this troubled time that we're in. And also, bees add to our food security. Right now, we're in a situation of very much food insecurity around the globe, and that's brought on by some aggression in Europe. And I'd like to just say that nothing spells political unrest like a hungry populace. And bees help to alleviate some of that hunger and poverty. They only provide about a third of our diet, but it's the important third of our diet. It's the fruits, nuts, and vegetables that really enrich our diet. So they're not going to alleviate food insecurity, but they can go a long way towards enriching our diet. I'd also just like to say a word about the veterinarians and bees and the work that's been going on for a number of years now. When I speak with veterinarians, in their traditional training, they look at dogs, cats, cows, chickens, and bees are unique. Bees are this super organism, and they don't stay put. They fly, they cover a wide range of area. So as a veterinarian, you really have to think differently, and you have to learn a bit about bee biology to understand. It's very hard to vaccinate bees. It's very hard to, anyway, it's just this continuous body that changes over the season. So I applaud your effort in education, and we'll work together to help educate ourselves about bee health and bee biology. So I'm going to close with a few invitations. We host a meeting every 2 years, a world meeting called the Apimondia Congress. I invite you to Istanbul, Turkey, the 24th through the 28th of August this year, so right away. And in fact, some of us will be there from this organization, hopefully to meet again. If you can't make it to Istanbul, in Santiago, Chile, we'll meet in the fall of 2023. If you can't make that, we'll be back in Europe in 2025. So we have 3 bids, and stay tuned and watch for that. We'll have a meeting back in somewhere in Europe in 2025. So again, thank you to all the speakers, and thank you for the topic. It's very important. Bee health. Healthy bees produce more food, and healthy bees can relieve some poverty. So from Apimondia, thank you, and glad to be a part of it. Thank you, Ivana.
Thank you all for your nice greetings. And I also am very pleased to say that today we have more than 450 registered participants now in this symposium. I think it is a really nice number of participants. Before we start with the presentations, I would just remind all of you that there is one question and answer button where every participant can ask the questions for each of the presenters. So during each of these presentations, we will collect the questions, and then regarding the availability of the time, because we have to be in a schedule, we will ask some questions directly, and all other questions will be answered in the texting by speakers in the following days, or sent by email to the all participants. So the questions that will be asked in the chat will not be considered. So please be caution and put your questions in this question and answer button. Okay, so as we already heard the first presentation, was from Dr. Andrea Maroni Ponti from Italy regarding the new animal health law implementation in Italy. So we have a few minutes left. If somebody has some question, maybe you can directly ask Dr. Ponti if something is not understandable during the presentation. Is there any questions? So if not, maybe we can then start with the second presentation. It is from the Dr. Francois Diaz from the World Organization for Animal Health and Resilience Department. I will just introduce one more time. So Dr. Francois Diaz, now you can present the content of your presentation, please.
Thank you. So can you see the presentation?
Yes.
Okay, thank you. So good afternoon. I'm François Diaz, and I work at the headquarters of the World Organization for Animal Health in the Preparedness and Resilience Department. I'm going to present you today the activities of the World Organization for Animal Health related to bee health. So I'm going to present first an overview of the organization, then related to or relevant for bee health, the World Animal Health Information System, the standards, and finally other initiatives of the World Organization for Animal Health relevant for bee health. The World Organization for Animal Health, or WUA, historically known as the WAI, is an intergovernmental organization created in 1924. The headquarters is based in Paris, and there are 13 regional and sub-regional representation based in the different regions of the world. There are currently 182 member countries or territories. The mandate of the organization is to improve animal health, veterinary public health, and animal welfare worldwide. The standard, guidelines, and recommendations developed by WUA are recognized as reference documents for animal health and zoonoses by the World Trade Organization in the framework of the Agreement on the Application of the Sanitary and Phytosanitary Measures. You can see on this slide the structure of the organization. The World Assembly of Delegates is the highest authority of the organization. It comprises the delegates of all member countries or territories. The delegate is a representative of the member country or territory to the World Organization for Animal Health. Most of the time, he or she is the chief veterinary officer of the country or territory. The World Assembly meets at least once a year during the general session, which is held every year in May in Paris. The Council represents the Assembly during the interval between general sessions. It is composed of 9 delegates representing all the regions. The Director General leads the organization. The headquarters work closely with the regional and sub-regional representation, the specialist commissions, and working and other group composed of elected or nominated experts. The headquarters work also with a reference center that we will see more in details in this presentation, and with the regional commission, which are composed of the delegate of each of the WUA members of the 5 following regions: Americas, Asia Pacific, Europe, Africa, and Middle East. So, first of all, it's important to mention on which bees the World Organization for Animal Health works. The organization addresses honeybees, which are species of the genus Apis. While about 20,000 species of bees exist, only 8 species of honeybees are recognized: Apis andreniformis, Apis serrana, Apis dorsata, Apis florea, Apis kochniwnikovi, Apis laboriosa, Apis mellifera, and Apis nigrocincta. These are the species on which the World Organization for Animal Health works. However, the standard and guidelines were developed more for Apis mellifera. And also we can notice that for one disease, which is a small hive beetle, the World Organization for Animal Health also addresses the bombus and stingle bees. This symposium will provide an opportunity to see if the biosecurity measures for Apis mellifera are also relevant for the other species of honeybees, or if there is a need of specific measures. You can see, so on this slide, the worldwide repartition of the different species of honeybees. And you can notice that except Apis mellifera, which is spread worldwide, the other species of honeybees are mainly in Asia. And so, one of the main mission of the World Organization for Animal Health is the transparency regarding animal disease worldwide. The new World Animal Health Information System, better known as WAIS, is an internet-based computer system that processes data on animal disease in real time and then informs the international community. Access to this secure site is only available to authorized users, namely the delegates of the different WA member countries, and their authorized representative who use WAIS to notify to the World Organization for Animal Health on the relevant animal disease information. This system consists in two components: an early warning system to inform the international community by means of alert messages of relevant epidemiological events that occur in the different member countries, and also a monitoring system in order to monitor all the WA listed disease over time, so either presence or absence of the disease. All the members of the World Organization for Animal Health shall notify to the World Organization for Animal Health of their animal health situation on a 6-monthly basis and of any exceptional epidemiological event within 24 hours. This is applicable to a limited number of diseases listed by WA, and this number was 119 in 2022. But also, there is this notification compulsory obligation for emerging disease with a significant morbidity or mortality rates or of zoonotic potential. Regarding bees, honeybees, we have 6 diseases listed by the World Organization for Animal Health: acarapyzosis, American and European full brood, small hive beetle infestation, tropilailaps infestation, and varrosis. So you can see on this slide where to find the information on the website of the World Organization for Animal Health. So you have two, you can scan, and you have 2 QR codes, one to access to this web page, and the other one to access directly to the WAIS web page. So now regarding the standard, the WUA standard are mainly laid down in 4 publications: the 2 codes and the 2 manuals for terrestrial and aquatic animals. The standards are adopted through a transparent process by the World Assembly of Delegates, following the principle of one country, one vote. The World Organization for Animal Health has developed and publishes different standards related to bee disease. These standards are mainly laid down in 2 publications: the Terrestrial Animal Health Code and the Manual of Diagnostic Tests and Vaccine for Terrestrial Animals. So you can see that all these standards are available on the EE website. And so the Terrestrial Code, so one of the 2 publications where you can find the standard on honeybees, the Terrestrial Code is intended to assure the sanitary safety of international trade in terrestrial animals and their products, as well as provide standards for the surveillance and control of animal disease. For honeybees, there is several relevant chapters. There is the chapter 4.14 on official health control of bee disease. This chapter provides information on the organization of the surveillance and control of bee disease at the national level. You have also the chapter 5.10, providing models of veterinary certificates for international trade. And you have the chapter 9.1 to 9.6, covering the 6 honeybee diseases, including in the WUA list. You will find in these disease-specific chapters information on the safe commodities, the determination of the disease status in a country, zone, or compartment, and the recommendation for importation of live bees and products of bees. You can see on this slide where to find this information on the terrestrial code. And again, you can scan the QR code and you will have access directly to the terrestrial code webpage. And the second standard publication where you can find standard on honeybees, it's the terrestrial manual. The terrestrial manual provides internationally agreed diagnostic laboratory methods and, when relevant, requirements for the production and control of vaccine and other biological products for all the WHO listed diseases, as well as several other diseases of global importance. For bees, the relevant chapters are some of the introductory chapters, such as the one on validation of diagnostic test method, or the one on the transport of diagnostic specimens. You have also the disease-specific chapter for the 6 bee diseases listed by WHO. We can also add to this chapter an introductory note on bee disease and one chapter on the bee disease nosemosis. And again, you can see on this slide where to find on the WHO website this standard, and you can scan directly this QR code to have access to the terrestrial manual webpage. So now, expertise, it's another important mission for the World Organization for Animal Health. The organization relies mainly for this on its network of reference laboratories and collaborating centers. You can see on this slide the repartition and the number of reference laboratories and collaborating centers worldwide. The World Organization for Animal Health has 2 reference laboratories related to bee disease, one in France for the 6 WHO-listed bee diseases, and the experts are Dr. Marie-Pierre Chauza and Dr. Stéphanie Franco. You have also one reference laboratory in Germany for varroa, small live beetle, and American fullbrood, and the expert is Dr. Mark Schaefer. You have also, as expertise, collaborating center. And the World Organization for Animal Health has 2 collaborating centers related to bees. One in Kenya on bee health in Africa, and one in Italy on good beekeeping management practices and biosecurity measures in the apiculture sector. Also, another part of the expertise, it's the mission of the World Organization for Animal Health rely heavily on the veterinary services of each member countries. It's the reason why, in parallel and in synergy with the development of standards, the World Organization for Animal Health provides a continuing support to veterinary services and laboratories to enable its members to implement them. And examples of such support, which is relevant for bees, it's the laboratory tuning program, which is an exchange of expertise between a WHO reference center and another laboratory. Also, the World Organization for Animal Health works also collecting, analyzing, and disseminating veterinary scientific information related to bee health. While rather old now, you have 2 major publications. One, it's Bee Health and Veterinarians that can be ordered online and available free on internet. You have the WHO bulletin, Protecting Bees, Preserving Our Future. And it's the end of my presentation. Thank you very much for your attention. And if you have any questions, the floor is for you. Thank you.
Thank you very much for a nice presentation. Please, Marco, can you check if there is any questions for Dr. Diaz? If there is some questions, please read it.
Until now, no question.
No questions. Everything is very clear and concise. So, okay, I maybe can a little bit put some comments on this relation between the veterinarians and beekeepers. So there is, let's say, a real problem in this sector because a very huge number of European and world scale veterinary faculties don't have any subjects regarding the honeybee biology and diseases in their basic curriculums. And that is pointed as a problem, but also I can say in front of the Federation of Veterinarians in Europe that we done one nice let's say, research on questionnaire regarding all authorized veterinary faculties in the area of Europe, when we concluded that around 50 of these high veterinary facilities don't have any subjects regarding the bees, but also stated that in all these countries, the veterinarians are really responsible for controlling and eradication of the diseases. So in that aspect, it's really good to know that there is some projects organized by the Federation of Veterinarians of Europe for example, students of the veterinary medicine which don't have the possibility to listen anything about the honeybee diseases in their own faculties, are able to attend some summer schools or some other streams of education at the faculties which are implemented these veterinary medicine practicals for many years and has a nice tradition. Also, it is good news that a few of the veterinary facilities also will introduce very soon the new subjects regarding this problematic in their curriculums as obligatory or as elective subjects. Okay, that was just a comment. So do we have any questions in meantime? Marco, if there is no questions.
No question, just a reminder.
Okay, thank you. So in that case, maybe we can start with the next presentation. And the next one is Dr. Subramanian Sevagan. It is, or she is a principal scientist in the International Center of Insect Physiology and Ecology, Nairobi, Kenya. He is over the 16 years of research experience on insect science in Africa, and his major areas of expertise are integrated pest management, biopesticide development, and beneficial insects. He heads the environmental health team at ICP and OIE Collaboration Center for Bee Health in Africa. So I invite Dr. Sevagan to give his presentation.
Are you able to see my presentation?
Yes.
Okay. I hope you're able to see my presentation and you're also able to hear me clearly.
Yes, we hear you. Yeah. We saw the presentation, so.
Yeah, thank you. And first of all, I'd like to thank the organizers for giving us this opportunity to present our work in Africa. I'm making this presentation on behalf of the team of scientists who are working with me here in the environment health team at ICP. And for people who are not aware of International Center for Insect Physiology and Ecology, we are based in Nairobi, Kenya, but we work across sub-Saharan Africa on various insect-related issues, whether it is for plants, animals, humans, and also for the environment. And within the environment is the place where we look at beneficial insects like the honeybees and the stingless bees, which I'll be talking about today. Beyond that, we also look into edible insects and other beneficial insects in this theme. So with that brief introduction about ISIPI, I'll quickly move on to the topic. Bees and the pollination services contribute a lot, both as economic inputs into the smallholders in Africa. The annual value of pollination services in Kenya is estimated around 186 million US dollars, while in Ethiopia it is estimated at 15 million US dollars. And most of this benefit comes from the honeybees, as you see here. Beyond honeybees, there's a whole range of other bees that also contribute into the pollination services in Africa. And I've just given a quick snapshot of some of the groups of bees that are here, which includes the stingless bees also, which I'll be talking about. Recipe, we look at creating livelihoods for smallholders in terms of beekeeping, and one of the major programs that we are currently implementing is in Ethiopia. It is funded by the MasterCard Foundation, and we call it as More Young Entrepreneurs in Silk and Honey and Beyond. And this program, our target is to create gainful employment in both beekeeping and sericulture for more than 112,500 women and youth. And as of now, we have engaged at least 72,000 youths and women in Ethiopia. And we have created jobs for more than 21,000 people. We have also contributed to the bee farming accessories. More than 88,000 hives and apiaries have been provided to the beekeepers in Ethiopia. Here you see a farmer, bee farmer, happily presenting his honey. Beyond enabling them to come up with improved beekeeping practices, we also support these groups in terms of getting organic certifications and creating value for their product. Very recently, the honey products from Amhara region in northern Ethiopia has been certified for organic production. We are also mindful of the various challenges that the bees face in Africa, and in this regard, through the support of European Union and also the World Organization for Animal Health, we have established a kind of a network of bee health monitoring and management facilities with a nodal organization based in Nairobi, TCP, and we have satellite labs at Burkina Faso, Ethiopia, Cameroon, and Liberia. These were active when the European Union funds were there, but currently the European Union funds have ended, but we still have a very close collaborative relationship with all the satellite centers, and we still keep monitoring some of these issues. So within this bee health monitoring program, we also develop tools and strategies for management of bee related challenges, and in this regard, we have developed a plant-based repellent for the varroa mites and also the small hive beetles. And we also established marketplaces around in Africa. 16 honey marketplaces in 8 African countries have been established, and we have trained a lot of National Agriculture Research and Extension System partners in 21 Anglophone and 28 Francophone countries, with more than 36,000 beneficiaries trained in beekeeping technologies. But all in all, this major review that came about in 2021, where ISIPI also contributed, clearly indicates that the challenges that might influence the bee decline and pollination in Africa, as you might see on the left-hand side, are not well established or are inconclusive here in Africa. So the more detailed informations need to come out from Africa regarding the bee decline and constraints that bees face in Africa. And some of the challenges that beekeeping faces in Africa are related to climate change, landscape degradation, and also invasive and other biotic threats, and intensive agriculture practices, not throughout the continent. At some instances, especially for high value crops, the agriculture is a bit intensive here. And also when invasive pests like locust and others comes in, the agricultural pest management practices are a bit intensive, which can also influence the bee decline. So I'll be taking you through some of the studies that has come out recently from our group. We are trying to understand the potential of climate change on bee diversity through a study that we conducted across altitudinal gradients in the eastern Afro-Mountain region, in the Taita Hills, and also in the Kiambu region of Kenya. And what we found is, as we go up the altitude, the diversity of bees declines, and all the indices, alpha diversity, gamma diversity, or beta diversity, which defines the various species richness in the region, declines with the increase in the elevation. And then one of the major reasons that contributes to the change is it is directly related to the floral alpha and beta diversity in the region, and climatic factors like mean temperatures and precipitations also influence both the floral diversity and also the survival of the bees. So with climate change, we anticipate that these factors will contribute to the bee diversity in Africa, and also the services that we get from these bees in Africa. This is another study which was done with the support of the Ministry of Foreign Affairs Finland, and through a program called as Aferia by our partners in the York University, where they engaged with various stakeholders in the Afro-Mountain region to understand the various factors that contributes to the bee effectiveness, which includes deforestation, pesticide use, and also the climate effects as related to water availability and floral resources in the region. What was observed is in different altitudinal regions, different factors influences the bee effectiveness. For instance, in the higher altitudes, pesticide use, deforestation, and land use conflicts are major factors that contributes to the declines the effectiveness of the bees, while in the lower altitudes, issues like water availability, drought, and other things plays a major role in impacting on the effectiveness of bees. So these are some of the climatic factors and also the landscape factors that influences the bee health in Africa. We have also been monitoring the pesticide residues and its effects in honeybees in Africa. As you might understand that pesticide use levels are quite significantly low in Africa, apart from some few high value crops where higher levels of pesticides are used. So what we observed is the residue levels in honey samples from Kenya, Ghana, Uganda, and Ethiopia are mostly less than the minimal residue levels prescribed by the European Union. But among the different classes of pesticide residues that we observed, though it is lower than the levels, insecticides and fungicides and herbicides are major, followed by acaricides, which also indicates the lower use of acaricides in bee and other ecosystems. Something that to be mindful of, and that we need to continue to monitor in some of the samples, especially around the high value agriculture systems, neonicotinoids were observed nearly 3-folds of the minimum residue levels prescribed, which is of concern, which might have to be monitored closely. In terms of the various pests associated with the African honeybees, the major pest that occurs on African honeybees are the varroa mites, varroa destructor, and also the small hive beetle, Ethina tumida. With regard to the tracheal mites, it is also widespread, but the prevalence and the distribution of tracheal mites is not well recorded in Africa. This is a map that was presented by Professor Perk from South Africa in his continental-wide review, and this clearly says both the varroa mite and tracheal mites are widespread in the continent. In some locations, both of them are present, while in other locations, one of these two mites are there in bees. Apart from these, the other major pest that occurs are large hive beetle, Oplostomus species, and also the greater waxmoth Caleria melonella. Compared to what we see in the US and the Europe, the bees in Africa tend to have kind of resistance to varroa mite. We see varroa mites around, but then they are not major causes for the decline of bees over here. So we have been looking at this through the years, and here I would like to present some of the papers that came out. Nyanganso et al. In 2017, we observed the hygienic behavior and grooming behavior in African and European honeybees. And one thing that came out is the African honeybees are less infested by mites right away. And in terms of grooming behavior, the Apis mellifera scutellata, the mountain bees in Africa, the grooming behavior was better expressed than the Apis mellifera hybrids of European origin. And this was observed with new classes of damage caused to the mites by the grooming behavior by the bees. Subsequently, in another study, we also try to do a more detailed analysis of the hygienic behavior by implanting mites into some of the hives and also comparing it with control brood cells. What we could observe is the Apis mellifera scutellata, the Afro-mountain, the bees have a much higher hygiene behavior as compared to the others, and moreover, with the presence of mites, this hygiene behavior tends to be also a bit more effective, which clearly says that there are volatiles that might be coming out of the mite-infested broods, which induces this hygiene behavior also in Apis mellifera. Currently, we have a PhD student who is looking into the genetic basis of this resistance to varroa mites in Africa, and we will be coming out with some information very soon. Apart from this, in another study, we also observed that the mites in itself had a low fertility, fecundity on the African honeybees as compared to previous reports from other regions. We also looked at the role of propolis and their extracts, which against varroa mites. Propolis, the quality of propolis also is dependent upon the agroecology that where the honeybees is placed. And what we observed is crude propolis and its volatiles are not pesticidal against varroa mites, but then ethanolic extracts of the propolis clearly had negative effects on the varroa mites, as you might see here in the graph that I presented on the right. Moving on from the pest, in terms of pathogens associated with African honeybees, most of the pathogens observed outside Africa is also seen here. The major pathogen that is of concern is the deformed wing virus, which is seen here much widely. I'll be talking about the information on the diversity very soon. Yeah. I'll quickly move on from the honeybees into stingless bees. We are also looking into the pest associated with stingless bees in Africa. And in terms of pest, the small hive beetles, Ethina tumida, and also the phorid flies, Megacilia scalaris, are the major issues in the stingless bees. And across the species complex, these two pests cause damage. And the proportion of infested hives is directly proportional to the proportion of damaged hives. So clearly, these two pests are of economic significance in all the stingless bee hives, stingless bee species in Africa. Beyond the pest in stingless bees, fungal pathogen Pyronellia pomarum is the major fungal pathogen that is observed in stingless bees. And what we have seen is among the 7 species of stingless bees tested, 4 of them were susceptible. Meliponula bocandae, Togoensis ferruginea, and Lendeliana are susceptible to the fungal pathogen, and the infestation levels were ranging between 20 to 33%. But then this was not directly correlated with the absconding level. So the absconding might be influenced by these and also by other factors in the ecosystem. Apart from the fungal pathogen, we have observed the viral pathogen, the bee queen cell virus. This virus was detected in worker bee samples of 3 stingless bee species, Hypotrigona gribodoi, Meliponula lindeliana, and Meliponula bocandae. But how far this is impacting on the biology of the stingless bees and also the yield of the honey, we still need to get more data on that. I'll quickly move on to my concluding slide. Some critical knowledge gaps to be addressed in Africa. More detailed information on the varroa mite haplotypes in Africa is needed. We all know that the Korean haplotype is the most devastating one. There are information that this haplotype is present in Africa, but then how far it is spread is not there. So we might have to have more detailed surveys. One of the challenges in Africa is most of the bee colonies are wild, and the managed bee colonies are very sparse. That could be a challenge in terms of surveillance. Diversity of deformed wing virus in Africa needs to be unraveled much more in detail. and strengthened surveillance for future threats such as the Asian lilapid parasitic mite, Tropilapes mite is needed, and a unified protocol for pest and disease monitoring in bee colonies across the continent is needed. More detailed assessment of the pest and the diseases of stingless bees is also critical, because we are currently domesticating stingless bees, and we have also technologies for farming them, and the honey is 3 times valued as compared to the Apis honey. So clearly there is an opportunity to look into the pest and disease constraints of stingless bees in Africa as well. Apart from these two groups, the Africa doesn't have a lot of bumblebees, but then definitely we have the carpenter bees, which can be key players in the pollination. We also need to look at some of these carpenter bees challenges as well. Yeah. With that, I would like to acknowledge the core donors of ISIPI, who have supported us in one or the other way for all our research work. Also, I'd like to thank you for your patient hearing, and I'm happy to take any questions that might come up from the participants here. Thank you.
Thank you for a very nice and detailed presentation. So firstly, I will ask, is there any questions?
No question.
No questions, nothing. So then I can take up this opportunity to ask something. You mainly speak about the parasites and pests, and I'm interested, is it really true that in Africa there is no problems with the honeybee brood diseases? Or if there is some, what you can comment about the presence and the distributions of these brood diseases?
Okay, there are instances of brood diseases in Africa, but then their impact on the honeybees are not as significant as in other regions. But this is also something which I would say, with detailed surveillance across, we will get more and more information as we go on. But as of now, they're not a major challenge, especially in African honeybee farming. Yeah, less intensive farming. Yeah.
Okay, thank you very much. So if there is no more questions, then we can proceed with a new presentation. I will invite Dr. Giovanni Formato. Just a second, I need to introduce you first. So Dr. Giovanni is head of the apiculture laboratory of IZSLT Institute. He is a person in charge for the OIE Collaborating Center for Good Beekeeping Management Practices and Biosecurity Measures in the Apiculture Sector. Then head of the FIO Reference Center for Apiculture, Health and Biosecurity, and member of the Bee Health Scientific Commission of the Apimondia. So many very nice functions, let's say, regarding this beekeeping sector. So you're welcome to present your presentation. And the title of the presentation is the Biosecurity Measures for the Honeybee Diseases in Europe.
Thank you very much, Ivana. I'm very happy to be here today with so many experts from all over the world. I acknowledge all them to participating, because today it's 1 year that we received the nomination of the OIE Collaborating Center, now the WOAH Collaborating Center for Good Beekeeping Management Practices and Biosecurity Measures in the apiculture sector. So I try to go ahead. So yes, the content of this speech is concerning good beekeeping practices, biosecurity measures, and some case studies that are deriving from our field trials in central Italy. So the good beekeeping practices we defined together with a partnership of a European project called Bee Practices. There were around 8 partners from Europe, and we provided these definition that are all those integrative activities that beekeepers apply to beekeeping production to achieve optimal health for people, honeybees, and the environment. This means that under the One Health approach, good beekeeping practices represent the basis for the sustainable beekeeping and the basis for bee health, human health, and environment protection. They are very generic and universal approach, and they have a broad common meaning, are not specific to any disease in particular. To provide you some example, to provide the bees a proper position, to provide the bees a proper use administration of medicines, to receive training, to avoid stress to the bees, to guarantee feed and water, etc. On the basis of the good beekeeping practices that we classified with this international group in a total of 140 practices. We could classify the good beekeeping practices in 7 headings that you can find here listed. There are practices related to the general apiary management, practices related to the use of veterinary medicines, the practices related to the disease management, hygiene, animal feeding and watering, record keeping and training. We used these headings according to some guidelines that were provided by the past named OIE and by FAO in collaboration. But now we go to face the biosecurity measures in beekeeping.
Giovanni?
Yes?
Are you sharing your screen? Because we don't see the slides.
Oh, really? I am in full presentation. Sorry, I try again. I'm very sorry. It could be very boring. Now, can you see?
Yes, perfect.
Sorry.
Not yet.
I'm very sorry. I was following in full presentation, but you're not. Sorry, excuse me.
I'm also sorry because I thought that you have some introduction.
Oh, very long. Can now you see it? Now I share the screen in full. Yeah. Okay. Is it okay? Can you see?
Yes.
Okay, now we speak about the biosecurity measures in beekeeping. They were defined by this group of people in the context of the Bee Practices project. You can see the logo here on the bottom right. And we defined that these biosecurity measures in beekeeping, like all those operational activities that are applied to reduce the risk of introduction and spread of specific honeybee disease agents. Our definition is very similar to the one that was provided by the European Regulation 2016/429. That is a little more technical, but the meaning is exactly the same. So the biosecurity measures in beekeeping are strongly related to specific diseases. And this means that the biosecurity measures in beekeeping, differently from the good beekeeping practices, they may change strongly by one country to another, depending by the presence of the disease, by the factors that are related to the disease, like the genetic of the bees, the geographical area, the economic impact of the disease, the climatic conditions, the beekeeping technologies, and even the health legislation that must be kept into account. So if you have to destroy some colonies for a specific disease, that is the measure that you should follow. There are no other chances. So you can see how even the legislation may impact on the biosecurity measures in beekeeping. Sorry. Okay. In this working group, we identified 56 measures, considering the main honeybee diseases that we have in Europe. So now we are speaking about the biosecurity measures in Europe.
Giovanni, you stopped the sharing.
Sorry.
Because you clicked on somewhere, probably.
I'm very sorry. When I push enter, it interrupted the presentation.
Just go with the arrows to move the slide.
Yeah, very sorry. Now? Again. Okay, so can you see now this? So this is the next step that we would like to follow. That now we have the list, at least a shared list of biosecurity measures in beekeeping according to the different diseases we have in Europe. So just to provide you some examples. For varroa mite, it was considered very important to have the hives with screened bottom board. And it works in Europe, but if you go in some other countries, like where I am now in Saudi Arabia, it is not possible to provide the bottom board of the beehives with the screen, because the heat enter in the hives, and the bee have a much more serious problem than varroa. So as you can see, these biosecurity measures is not applicable to the Saudi Arabia condition. So as I was saying, now we have the main list of measures, but we need now that these measures should be adapted, tailored in each geographical region. This means that these biosecurity measures list that you can see here must be validated at the geographical level, and so they can become best practices. This is something we would like to do with another project that is called Be the Net, and that we start from the September 2022. So, but I would like to stress about the discussion, to stress the discussion this evening, this evening here in the other part of the world today, about the use of the antibiotics. So for sure, we are not discussing about varroa, because as you can see, the biosecurity measures for varroa are listed here. So it's very important in general, and it is frequently underestimated, the presence of this mite all over the world. So it's very important to monitor the amount of varroa and to check the signs of varroa or viruses that are related. And again, it's very important try to prefer soft acaricides. Here, this is something related to the discussion about antibiotics that I would like to open, because now the future of beekeeping is looking at sustainability. So it is very important not only to guarantee the health of the bees treating the bees. It's very important even to consider the sustainability of the treatments that we apply. So concerning varroa, I think it's very important trying to use soft acaricides. This means organic acids, essential oils, anyhow, acaricides that are not persistent in the hive products, or are less persistent in the hive products, and that do not provide strong impact on the environment. So this is something related with the discussion I would like to open on the antibiotics. But so it is important trying to prefer the use of soft acaricides for this sustainable approach that is the modern approach in beekeeping. We must go ahead. No? Then it's very important to rotate the active ingredients of acaricides. And in some countries of the world, there are no acaricides registered. This is like oblige beekeepers to make illegal treatment, and it is not fair, you know. So we don't have, you don't only must know how it should be. We must even have a context where beekeepers are allowed to follow the rules. And the beekeepers must support it with a proper regulation. And of course, the treatment of all the colonies in the same apiary is very important, as well as the treatment of the apiaries of the same area. This is something that can be done only with a strong collaboration between beekeepers, first of all, and after between beekeepers and the authorities, that they can support beekeepers in choosing strategies and when apply the strategies. Okay, I interrupted again, right? Because, sorry, I'm very sorry. Sorry. Because I'm used to push enter to go ahead. So. Now you can see again, right?
Yes.
Okay. So I want to speak shortly about American full brood and European foul brood. So it's very important here not to treat with antibiotics. Now I've seen in some countries, many countries, like I was first writing a note in the chat box about the spread of American foul brood in South Africa. It happened some years ago. I was there and I heard about this fear of beekeepers there. So yeah, I would like to ask even to Subramanian if he had some input from this side as well, or if it was something that is now passed. But as well as these diseases, we have nosema, and it's the same. The beekeepers, when they have not very clear instruments to treat, they approach fumagillin. And as Dr. Junxia from FAO said, we saw that the use of internet is very frequent to gather antibiotics. So it's very important to have this approach that antibiotics should not be the first option, but that probably they should be the last, or better not to use. It again depends by the different legislations we have. So we considered in Europe it's not to treat with antibiotic the right way to gather the sustainable beekeeping. So we need to use proper measures to reduce the possibility of using, to reduce the need to use antibiotics. This means to change frequently the combs, to have young queens, to monitor the presence of American European foul brood, to have fast intervention, eliminating the symptoms, the symptomatic case, as well as it's very important even to have early prevention, have early diagnosis, even using where it is possible, modern diagnostic methodologies like PCR, adopting the debris. It's very interesting to use the debris during winter, that the bees are wintering, and you can verify if there is a risk of this disease in your apiary, and that in a specific colony, you can then go to change the combs in spring. I go ahead. I would like to go ahead. Doesn't work. Okay. For nosemosis, again, for sure, not to use fumagillin and then renew the combs. Professor Higes, I frequently said to be careful even to varroa. So varroa is even related. If bees are stressed because of varroa, they can even easier have higher infection levels of nosemosis. So do not reuse combs originated by depopulated or collapsed hives. Monitor the infection levels. So here again, we have again the need of the laboratory that should be close to beekeepers. So laboratory has very important role, as well as the extension services, as well as veterinarians. So there is the need to put in relationship, strongly relationship beekeepers with the diagnosis of the diseases, so they can have awareness of what they have and they can intervene properly. So it's important to know the idea of the infection levels of Nosema, keep young queens, and where possible, trying to adopt a selection program for Nosema resistance. Okay, so now we are in the last part, that are the case studies about, as I wanted to tell you about the antibiotics. We know it's not a good habit to use antibiotics. In many countries, they are forbidden. But let's see why. Okay, we know many reasons. Because the beekeepers get used to use antibiotics, and it's difficult then to stop. It's a kind of drug, right? That they are used to treat, and after, well, if they stop, the disease increase, and he have to treat again. And in many cases, antibiotics induce may even foresee the relapses of the disease. So it's not a solution, complete solution. So we know those aspects, as well as the problem of the residues in the hive products. We already know that. But let's go to see what happened in the untreated colonies. So here we have one case. It was summer 2020 in Rome, where we treated an apiary. We treated a part of the apiary. As you can see, I don't know, can you see the harrow? Can you see my harrow here?
Yes, yes.
Okay, so in the first line, you have the PPB we could find after 1 week from the treatment, 3 weeks, and so on. Okay, you can see the amounts of the oxytetracyclines, that residues in the comb honey of the nest of these treated colonies. But the problem was the untreated colonies. Let's see what happened here. Here we have, again, even if the colonies were untreated, we found the residues. Okay, it could be, it is even more frequent in summer, in end summer, when bees go to search honey, even in the other beehives, especially those that are weaker. So we may have, because of this specific habit of the bees, the problem of persistence of residues in the colonies for many weeks, as you can see here. We have really low amounts of antibiotics for many weeks. This must put to our mind the one big problem that we have in One Health, that are the antibiotic resistance, right? So we thought, okay, probably because it was summer, bees have the habit to go sucking the other colonies. So it could be because it was summer. So we tried in spring again. Yeah, even it could be provided by the drift of the bees, or because of the drones. So we tried in March 2022, and during blossom. So we brought the colonies close to the almonds trees, you can see here, and we treated some colonies, other were untreated, as you can see here. As in 2 weeks, we have the reduction in the treated group of the oxytetracycline. Here you can see we have an increase in the untreated group, because why we have the increase here of the PPBs? Because the bees go to accumulate antibiotics from the treated colonies, right? And again, we have the problem of persistence of antibiotics inside of the colonies. It is another risk, for antibiotic resistance. And what we did, we thought to another problem that was what happened in the flowers. So we took some samples at different distance from the apiary, 5 meters, 25 meters, and 50 meters, and we check what happened 1 week, 2 weeks after. So we could find, unfortunately, even low presence of antibiotics even in the flowers. So again, we have here the problem of antibiotic resistance. So now what we are doing is isolating the bacteria. We already isolated them, and we are now searching for anti-oxytetracycline resistant genes in these bacteria of the flowers. So let us update next year when we'll have the results hopefully. But just to tell you, this is a very important aspect. We should consider these problems as specific of bees. And now I don't remember very well, someone in the opening told we should consider bees. Jeff Pettis, the president of Apimondia, yeah, he said veterinarians consider the bees with their habit. And I agree 100%. Bees goes on flowers, bees pass from one colony to the other. So even if we adopt traceability systems of the treated colonies, we must consider even the contamination of the untreated colonies. And this is something very careful to take into consideration, considering the antibiotic resistance, in my opinion at least. Let's go ahead. Okay, just provide you further readings on good beekeeping practices and biosecurity measures in beekeeping. As you know, sorry. Okay, the FAO provided through TECA, that is the provision of technologies for small farmers. This practical manual on how to identify and control the main diseases of the honeybees. This is a very short manual, practical, written in an easy way, so the beekeepers can find very interesting information. It was translated in some languages, and now you can find on the website what languages it is available. Another manual, another guide. These are guidelines for sustainable apiculture. It was published online this year, and I know it is translating now in some languages. If in your countries you have the possibility to translate these documents, please inform FAO, because it is very useful to provide beekeepers all over the world in their language the possibility to read information about the proper management of their animals. Sorry. Okay. And this is another important document, in my opinion, concerning the responsible use of antimicrobials in beekeeping. So veterinarians about this topic, they have very important responsibility, because they should follow the beekeeping sectors as they do for all the other animal sectors. Bees are frequently not at all considered. There are not veterinarians working on bee diseases. There is a big lack of information on bee diseases and on proper therapy, treatment. So if veterinarians don't do this, it's something that is very important and that is missing. It's their responsibility to invest on training of veterinarians on this topic too. Thank you for your attention.
Thank you very much for your nice presentation. So is there any questions from the participants?
Yes, there is one question for Giovanni. We have a small beekeeper working organically in Peru. And he asked, what can we do to collaborate and increase the concept of unique and global approach to beekeeping?
It's very important. I think it is very, very important. Everybody in the world should collaborate and can collaborate to this topic. And I think it's something that at the conclusion of this meeting we can discuss all together, especially with the international organization. They have a very important role, as well as the experts from all over the world. Should be very nice to make a joint table, working table. But let us discuss this with everybody at the end of this webinar, okay? Please be patient to this beekeeper.
Okay, thank you very much for your answer. So we are mostly in time according to our schedule. So I propose that we can use one short break now and proceed with the presentations in 4 p.m.
Good, thank you. Thank you, Anna.
Thank you very much. So Dr. Giovanni, you will proceed with the moderating after this break. So I'm really pleased to be with all of you till now. Thank you very much.
Thank you very much, Ivana, and thank you to FVE for the availability providing you.
Thank you.
Yeah, thank you. Thank you. Bye. Okay, hi everybody. So we are perfectly in time, and so let me introduce you, Dr. Jun Kim. So Miss Jun Kim is working as Animal Health Officer of the Food and Agriculture Organization of the United Nations. Her focus area of work includes implementation of antimicrobial resistance, utilizing the One Health principles and tools developed by FAO. So it's something very related to what we have just told. Please, Dr. Kim, proceed with the presentation. Thank you.
Thank you very much, Giovanni. Let me share my screen. Okay, I hope you can see my screen, and also please let me know if my sound breaks down, because I think this today is very weak Wi-Fi day for me. So it is my pleasure to present FAO's work on AMR with a One Health approach, especially those towards sustainable beekeeping. I would like to appreciate my colleagues at FAO and other partners institutions working closely with us and contributed to this today's presentation with me. So first of all, how does FAO support countries to combat AMR in general? As you know, antimicrobial drugs and their use are vital in treatment of disease. So we can protect both human and animal health from disease. However, the antimicrobial resistance, or AMR, we say, refers to the capacity of microorganisms to grow or persist even in the presence of antimicrobials. So here is the problem, the risk of emergence and spread of microorganisms which is resistant to antimicrobials, in which we may not be able to treat the disease with currently available antimicrobials. Also, AMR has a very severe impact to achieve the Sustainable Development Goal, or SDG, by 2030. Just to mention a few, SDG 1, no poverty, and SDG 2, zero hunger, and SDG 3, good health and well-being. In response to the global threat to affect health and our livelihood from agricultural production, the FAO Action Plan on AMR includes its objectives and activities under FAO's vision, a world free from poverty, hunger, malnutrition with a sustainable way. 5 objectives are outlined in this plan and also supported by respective activities. I'll just go through with you all the objectives in the action plan. First, awareness and engagement increased to foster change. Second, strengthening surveillance and research to support evidence-based decision. 3, enabling good practice to prevent infection and control the spread of resistant microbes. 4, promoting responsible use to keep antimicrobials working. 5, strengthening governance and allocating resources to accelerate and sustain progress. So food and agriculture sectors here, then what do we mean by the food and agriculture sectors? This includes livestock sectors, including the pig, poultry, ruminants, and then crops and plant, and then also aquaculture and apiculture sectors and its related environment. However, not only food and agriculture sectors alone can solve the problem concerning AMR. AMR, as you may be aware of already, is a multi-sector problem concerning human, animal, including bee, plant, and environment, which are closely interdependent. It means that overuse or misuse of antimicrobial in one sector can have impact on other sectors' productivity and sustainability. Therefore, it requires a One Health approach that ensures the integrated and unified collaboration to the issue. So now, specifically focusing on beekeeping and AMR, what is the problem and what does FAO do? As you see in the graph, according to the FAO's, that with available data ranging from 2011 to 2022, for the period time, the number of beehives has increased about 13 millions. Along with the increase, this is fair to concern widespread and bee disease could be more prevalent than ever before. Therefore, it may drive more use of antimicrobials, which will need our preparedness and actions against together. Again, a One Health approach is required to prevent and respond to the emergence of AMR in beekeeping and to safeguard our food systems, including human and animal health, including bee health and environment. In 2019, FAO has launched the international survey to understand the awareness and practice on AMR on beekeeping. The respondents were mostly from North America, UK, and the European Union. What we learned from the survey was there were high level of knowledge across the three regions for the antimicrobial residue and drug resistance infection. However, they acknowledged as well that antibiotics are used sometimes without following instruction in the label. And some North American beekeepers among three regions were more likely to use antibiotics for disease prevention rather than treatment and acquire them through internet frequently. And the group had the highest percentage of having witnessed the treatment failure against bacterial honeybee disease, such as American and European foulbrood. Overall, this was our first international survey launched by FAO, and we concluded that the survey is a very cost-effective risk management tool to reach international beekeepers in order to understand their awareness and practice. Following up on our previous survey cycle in 2019, FAO will continue monitoring the awareness and practice on AMR among beekeepers, hopefully every 3 years to manage the risk associated with AMR. And this is excellent collaborative approach that thanks to IZSLT, Apimondia, and Appalachian State University in USA. It will be launched in all FAO languages, including English, French, Arabic, Chinese, Russian, Spanish, and in the international platforms, including FAO AMR website, as well as our partners' website. And then we aim to open this survey until 31st October 22. So I really appreciate our beekeepers here could also participate in the survey as well. Other relevant work on beekeeping, just Giovanni mentioned, so I will not go very deeper on this. FAO has working to provide guidance on good beekeeping practice and biosecurity measure, including responsible use antimicrobials. This guideline was collaborative work again with IZSLT. The document, as you see here, titled Responsible Use of Antimicrobial, is a very comprehensive, having 5 agenda, as you see. And we introduced a progressive management pathway approach in beekeeping for the first time, and also the risk management tool, the surveys that I mentioned, so countries and also beekeepers could use for self-assessment as well. So now I would like to give some background on progressive management pathway approach for PMP. PMP that was introduced in FAO beekeeping guidelines and will be refined further for practical use in countries this year. So FAO's stepwise approach has long history, dated back to 2008, in which we developed it to improve the risk management capacity of high-impact animal disease, including foot and mouth disease and animal trypanosomiasis and brucellosis, rabies, and so forth. The philosophy is that it always starts from the assessment, as you see in the right screen in your right side. It always starts from assessment, that you understand at which level you are at. And then second stage is disease reduction. And third stage focused on disease elimination. And fourth stage focused on disease eradication. And the final stage focused on maintenance of those eradicated status for some disease, including without any vaccination. However, control pathway aims to disease elimination and eradication, while we cannot control or eradicate or eliminate AMR, because AMR is phenomenon and also it could happen naturally. So we can only we can only manage this AMR, not eliminate. So this is the example that as you can see as a figure, it's progressive management pathway for AMR, as just for example. It also has same approach while it has 4 stages. The first one starts always from assessment, and then through the small scale at local or provincial level, or third stage, nationwide awareness, nationwide approach with some sectors involved. And as a final stage, nationwide implementation of AMR activities in all One Health sectors involved. So as you saw the FAO action plan in the first slide, we have 5 objectives, and here in PMP AMR we have 4 pillars, which is awareness, evidence, and governance practice, but also responsible use of antimicrobials is incorporated in this pillar of practice. The reason that I give this background is because, as I said, we will work closely with IZSLT and other partners to develop the progressive management pathway for sustainable beekeeping. This aims to assist countries and beekeepers to implement sustainable risk management with good beekeeping practice and biosecurity measures, as well as responsible use antimicrobials. It again starts from risk assessment to understand at which level their awareness and practice are currently, and initiatives from the small scale toward a nationwide approach at third stage, and then as a final stage to maintain the sustainable implementation of such good beekeeping practice. So this is my last slide. As a way forward, FAO will continue to promote responsible use of antimicrobials in beekeeping to countries and beekeepers, and we will collaborate with global partners as well as at the field level. And tool and manual of the FAO progressive management pathways for sustainable beekeeping will be published, developed and published this year. And we will keep monitor the knowledge and awareness on AMR using the risk management tool among beekeepers. So I really thank you, and I will address any question or discussion.
Thank you very much, June. There is a question that is, where is the progressive approach from 2008 published?
So the 2008 is the very first time where we developed this approach, stepwise approach. So this is not about AMR or beekeeping, but this is about the high impact animal disease such as foot and mouth disease. So if you want, I will find the link and then put in the chat or Q&A box. I hope I addressed your question very well.
Very good. Thank you, June. Okay. I think there are not other questions. Marco, can you confirm there are not other questions, please?
The last one, a few seconds ago, risk management tool. Can you clarify, please, the concept?
Yeah, so the risk management tool is basically the survey that we also published in the guideline of the responsible use of antimicrobial in beekeeping. So this is the 3 surveys, having this on good beekeeping practice and biosecurity measure, and AMR and AMU. So this is basically the survey that you can identify the risk by assess, and also identify maybe the solution with the progressive management pathway. And also I may invite Giovanni as well, because he is very the expert that we work together, although you are now chairing.
Yes. Thank you, June. Yes, there is the step of the assessment that is done through surveys. To give you an example, now there will be very soon another presentation on the Oman, and we evaluated the management of the diseases and even of the medicines through these surveys. It was very useful because we could find some problems, and now we know how better address the problems we saw. Now with June, we are completing to study this approach, trying to find a tool that could be useful properly, exactly in management, trying to provide very more detailed information from the assessment, and even in providing the proper management toward the sustainable beekeeping in different countries. Thank you. Okay, so if you agree, we can proceed with the next presentation. That is from Dr. Fanny Atina. Fanny is a biologist and senior researcher in the Department of Apiculture, Institute of Animal Science of Elgo Dimitra in Greece. Since 2018, she is also the director of the Institute of Animal Science, and since 2019, she is the president of the Bee Health Scientific Commission of Apimondia. Please, Fanny, the floor is yours. Fanny, can you activate the microphone? We saw you just a few minutes ago.
Is that okay now?
Yes, perfect. Thank you.
Yes, you hear me. Good. Hello, good afternoon, good day. I'm really very happy to be here with you. And okay, now I think it's working. I'm very happy to be here with you. Thank you, Giovanni. Thank you, Ivana, both the moderators, but also I would like to thank the friends and colleagues from OIE, now the World Organization of Animal Health, and FAO, and also the Instituto Zooprophylatica for this invitation. For those that they don't know me, I'm a biologist and I'm working in a very small unit. Maybe it's even smaller than what you can think. It's a research unit in Greece. we are doing quite a lot of things, and through our collaborations, international collaborations, we achieve even more. Today, I would like to continue this very nice discussion for the biosecurity measures. And I would like to talk to you about a little work that we undertake with the Bee Health Commission, some of the members of the Bee Health Commission in Apimondia, together with some of the friends colleagues in FAO, for the biological hazards and a kind of a risk assessment that we did for the effect on Western and Eastern honeybee population. So I will also try, please let me know if the slides are moving. Is it okay? My slides have moved? Good, good.
Perfect.
So, perfect then. Okay, let's continue. So what are the facts? The facts are that the honeybee colonies are, we have still lots of losses in honeybee colonies, and this is questioning our practices from year to year. So something, maybe it's not that good. Climate change also is showing its effect on our business production, especially profits, because this is what makes beekeepers interesting. Then the beekeepers are more and more dependent on artificial feeding, veterinary medicines, even queens from breeding centers, sometimes even a few breeding centers per country or continent. And although we do have new technologies that they have been developed, still varroa and other pests or pathogens do suppress the health of our bees. In this presentation and in this work, we consider only the biological hazards, the biological variables, not the other ones that, as pesticides, for example, that the abiotic ones that they could influence. So it is, let's say, not the full One Health approach, but its focus is on the biological hazards. And the question is beekeeping sustainable the way we do it? And what is sustainable beekeeping, in fact? So by definition, sustainable beekeeping is the act of bee farming using principles of ecology in a way that bees, humans, the practice, our practice, but also the economy of the act are bound together in a relationship where the use of the organism, in this case the bees, respect the rules of their environment. And till now, today, in this very interesting webinar, we hear a lot about all these factors. In fact, we hear a lot about sustainable beekeeping. So all around the world, beekeepers and scientists, we are trying to find solutions and see and explain the reasons why we have colony losses or why there is variability that we experience from region to region. And we did hear that beekeeping is different around the world, we know that, but we also hear that the measures, the practices are different also around the world and in areas where we practice beekeeping. So just for us to understand, I put here two pictures of varroa and Apimondia, just to show us the invasive species, that they do cause quite a lot of damage in many areas of the world. But what I want to say is that the bees and the beekeeping is somewhere in the middle of, I would say in the middle of the world, but because other bees also interfering, it could be also competition. The agroecosystem, it is so important and it is influencing the bees. The bees are influencing the agroecosystem because the bees are providing the pollination services, but we are also so much influenced from the other communities, like the wild bees communities around, but also the weather, the climate, plus the landscape structure and the land use. And altogether, it makes the general concept under which we need and we are asked to work and to find solutions for the sustainability of the beekeeping, as I said before. We are also aware that mainly And if we forget the climate change for the time being as a climate, but still this is also an influence of the anthropogenic practices, the rest of the anthropogenic practices are also influencing the health of our bees, the health of the pollinators, and also they are different types of stressors that we need to tackle them in a different way. And the poor the beekeeper always in the middle, trying to save the bee that is in danger. So what we thought in Apimondia Bee Health Commission was that if we have a global evaluation of the impacts of these biotic stressors on the honeybees, and we have a better understanding of them, this could lead to relevant and efficient mitigation measures and can improve education pathways and create local adaptive strategies for sustainable beekeeping. Because as I said before, the factors that they can influence the bees and their health, there are so many. And although we are in this little work, we concentrated on the pathogens, parasites, not the genetics in this case, that they are inherent factors, together with the external factors. At the end, we have a very complex and a synergistic effects system. So our aim was to better understand, as I said, the impacts and the differences among the world's regions, the differences in the impact of the stressors. And the methodology that we used was kind of the expert knowledge elicitation procedure. So each expert graded each factor, that is the pathogen or the parasite or the predator, in each region, each one of us in its own region, Asia, Europe, Africa, North America, South America, and Oceania, against 5 characteristic effects, but using 6 predefined a priori classes. And I will explain. The 5 characteristic effects that we try to evaluate is if, for example, each one of these pathogens or parasites have a contribution in colony losses, or in loss in foragers, or we have brood losses, or there are other synergistic effects with other pathogens, so we have synergies with other pathogens, and at the end, if there is any cost of management. And we classify them starting from 0, like, for example, when one of these stressor is absent in a region, until 5, which is often, because we meet often, we find it often, and it's always in all regions. From what the result of all this evaluation came out to this nice table, because at the end we average and we sum up and average the ranking of each pathogen in our region for all these characteristics, as I mentioned. And what you can see and what is interesting is that the red colored cells are the ones showing most important and most impact of the pathogens. Orange is something like intermediate with green together, and blue, it's a smaller impact. At the end, the last column, what you can see is that we also try to do the same for Apis cerana, because mainly we worked with Apis mellifera. But then we did also evaluated the stressors for Apis cerana in Asia, and there you can see that there are more differences, and the stressors do not really have the same order in terms of their effect. We start with varroa. It seems that varroa, it is one of the main stressors in all around the world, and it's followed by the deformed wing virus, Nosema cerana, which is very interesting because we also identify this as an important stressor also in Apis cerana, and then following by Bacillus lavi and Aethina, and of course the hornets. Please do not take this as granted that you need to agree, or there is no other opinion on this. This is our expert elicitation, our expert opinion that can give a kind of a trend of what is really happening. But this can also show us what is important and how we can collaborate, or what is, which are the stressors that we should focus our collaboration between the regions. In conclusion of all this general evaluation, came out that when the pathogens or the parasite loads in honeybees get too high, there are high losses in brood or adult bees, sometimes even on the whole colonies, if there is no kind of adoption of a systematic approach for monitoring and prevention of each of these diseases or pathogens, even where there is a proper training and management. So we need the training, we need the management, but we also need systematic monitoring and prevention approaches. And good beekeeping practice and management with a proper application of the biosecurity measures, including guaranteeing systems or eradication of the invasive species, are very important. And we try to show this through some case studies that I will go through very, very quickly. For example, we presented this work, or we will present this work, a case study of, for example, managing the small-head beetle in Europe. And one good example is how we can monitor and have early detection results through going through the debris of the colonies. As, for example, you can see in this icon. Then if we move from Europe to Africa, we had a very good example from Algeria, where evaluating the susceptibility of the pathogens in different subspecies, of the Apis mellifera, like, for example, Intermissa and Sahariensis, you can see differences. And the differences are mainly in areas where both species occur at the same time, like in the south, for example, and you can see that the susceptibility is less because there are less losses, and at the same time you see that there are higher losses of Intermissa, for example, in the north compared to the south, because it is a subspecies really very well adapted to the arid and hot and dry regions that they are mainly in the south. Another example or a paradigm comes from Australia, and how in this country they try to keep beekeeping mite-free. It takes a lot of effort, it takes a lot of coordination, of monitoring, of prevention, of collaboration between beekeeping associations, honey producers, and the state, of course, to prevent any infection, any trade income, any importation of the pathogens of any mites, Propylalaps or varroa mite in Australia, and still till now all these efforts have been successful. And if we move, for example, to south to the Latin America, the example from Argentina can show us that one of the biosecurity methods, like, for example, the good use and the application of the hygienic behavior of the bees, the research and the monitoring of the colonies for their hygienic behavior, and the use of these results to the breeding programs can lead to, after 5 years already, they can have good results showing that colonies with showing higher hygienic behavior, they have less prevalence of American foul brood. And all this after the good use of biosecurity methods. The paradigm from North America says that we need to have strong colonies very early in spring, where we move them for almond pollination. So in order to have strong colonies, we need to supplement them with good pollen or substitutes or pollen patties, but in any way, we need to help them in order to keep them strong. Something that I also find very, very important in my own country, because many times we have such a dearth of pollen end of August, beginning of September. And in addition, after monitoring and monitoring the infestation level of the varroa, they know, and we also know, that this is the best way of evaluating the need of the colonies to be treated, and then treated with biotechnological methods or essential oils or organic methods, this way keeping them also chemical free. If we move then to Asia, for example, we see the effect of two mites, because this is an area where Tropilalepis mites, together with varroa, they can they have an impact on the colonies, and it's so obvious that although both of them, they do have an impact, Apis cerana colonies, they are less susceptible to all of them. And sometimes maybe they don't need to be treated, while Apis mellifera in Asia needs to be treated, unfortunately. So immediately we can see the adaptation and the different management practices. I would like to mention that the TECA platform that is holding by FAO is a very good tool for beekeepers, for scientists, for organizations to share opinion and also even discuss, and we all learn together. And this is one way of promoting the good beekeeping practices or the biosecurity measures and educating people that we should use this kind of platforms even more. And you can see more on the link. So yes, we talked about One Health approach, and we do believe in Apimondia that even human health is very much influenced by, of course, the environment where we all live and the bees as well. And something to consider for the next generations or for mitigation measures, it could be monitoring and prevention instead of treating. The trade control and mitigation measures should be taken into consideration and also in policy making. Education and training and knowledge sharing is very important, because we can never stop learning and we can never stop sharing knowledge. Nobody knows everything and we always learn more. And of course, we need to adopt these good practices and see what is the most efficient in our region after we evaluate them. Before I stop with this presentation, I would like to thank my colleagues for participating in this, and mainly Panawan Shanda Vanakul, that it was her idea to do this kind of a risk assessment of this biological hazard and present the good examples to others. And we are very sorry that we lost Panawan a few months ago. So this presentation and this work is devoted to her. But the last but not least, I would like just to mention that in Apimondia, we really care about the collaboration with FAO and the World Organization for Animal Health. So we would like to continue this collaboration, and it already has been shown through common publications, participation in the One Health approach, for example, meetings, but also the survey for the antibiotic use in beekeeping and the publication of good beekeeping practices. Also, I would like to mention that we are happy that Apimondia is also part of two big projects, European projects like the Insignia project, monitoring the environment pollutants through bees matrices and products, and also the Beethanet project that started from the Instituto Zooprofilattico, that starts now, that it will give us really a good opportunity to disseminate knowledge to the people. And with this, I would like to invite you to participate in our next Apimondia Congress, which is going to be very, very soon in Istanbul, because there we will have a very good opportunity to present the results, but also to discuss during roundtables, to take decisions, and also share knowledge. Thank you very much, all participants and colleagues. Thank you so much for your attention.
Thank you very much, Fanny.
Thank you.
For sure, Fan One is should be happy about this presentation. Please stay up to the end, because at the end, when we will close, we will discuss about this next meeting in Apimondia and the possibility to join together.
Sure.
Okay, thank you very much. Marco,
I'm here for any questions, though. Okay,
yes.
sorry.
Yes.
Yes,
Are there
sure.
questions, please?
Until now, no, there are no questions.
Okay. Thank you very much. So let's go ahead with the next presentation. That is from Professor Claude Segerman. Claude is a full professor of the University of Liège in the Department of Infectious and Parasitic Diseases of the Faculty of Veterinary Medicine. Claude is the director of the research unit in epidemiology and risk analysis applied to veterinary sciences, and is the chairman of the Biosecurity faculty unit. A research focus is dedicated to use epidemiological approach and risk assessment to understanding and to improving honeybee and stingless bee health, considering One Health, eco-health, and planetary health frameworks. Dear Claude, are you there?
Yes.
Yes, so please, the floor is yours. Go ahead with your presentation. Thank you very much.
Thank you very much. Show you my presentation.
Yes, we can see it.
Okay, perfect. Thank you. Thanks a lot of the organizer to invite me and to speak about prioritization of practice to prevent colony losses. It's a technical problem.
Claude, do you want me help you?
Yes, to pass. I have a problem with the pass of.
Yes, I had the same problem. Yeah.
Yeah.
Marco, can you open a presentation and go ahead?
Yes, of course, 1 second.
Okay. Thank you.
One second. Okay.
I show the presentation, but I'm not able to pass one slide by one slide.
Yeah. Second, I take it back. Here we are. Yeah.
Claude, you are recently back from Africa. Did you go there for these studies or other activities with bees?
Yes.
If possible to know, huh?
Yes, but I am concerned with this technical problem. You have a solution? Perhaps if you have the presentation, you show the presentation yourself, like this.
Yes, I will show it. Please stop sharing your screen.
Yeah, but the problem, it's completely.
You go on the top of the screen, it appears a menu, and you can stop sharing.
Okay, I think, no, okay, it's correct. No, it's okay. You find the screen?
Yes, but we see your second screen, so the presentation mode.
Yes, current, beginning with your authorization. Yes, the plan of my presentation is divided in three, a small background aspect, the proposed conceptual framework, and conclusion and perspective. In terms of background, of course, words without bees is not possible because honeybees is essential as product for consumer like honey, but also for its use by human, for example, for fruit protection, but also product use by beekeepers like beeswax. And it is an important pollinator and it's a very important role in terms of biodiversity. If you talk about the mortality rate of bees, of colony bees, we need to have an acceptable mortality rate to assess, but it depends in function of the country, of course. But just an example, in Belgium, you have the mortality loss in abscess and the density in Y abscess. And you find that in case of Belgium, 10% of acceptable mortality rate, it's correct. And based off a lot of observation, you find the number of your screen. Of course, the cause of colony loss is multifactorial. You find this in the previous presentation, but it's another proposal to show this. And it is very important to interest about this. And for this, we propose a conceptual framework that was divided in three parts. The first part, and I agree with the previous presenter, that the fact that this exercise is related to the context of area of interest. It should be changed in function of the continent of area. The first thing is the prioritization of disease, and you use frequently a multi-criteria decision analysis, like the ANSES proposed this by prioritization of a lot of disease, but I show this just after. The next possibility is a survey, and I agree with the monitoring. It's the first step, a survey using multivariate logistic regression analysis to target practice at risk or practice that was protective. Because if you have a practice that was protective, you increase this practice. If you have a practice that was pose problem, you decrease this practice. And for this, we have also the needs for direct action. We need action to evolve the situation. And by the way, in the case that was proposed to you this day, we developed two real-time tools, Beetoxwax tools and BeBestCheck tools, but I explain just after more about this. Of course, it depends of the level of acceptable mortality, and it's related to the previous slide. A third possibility is the same as explained before. In fact, it's you evolve and you aggregate different experts, and you have an expert elicitation about what is the best practice, and you relate this best practice with the true reality in the field, and you essay to give the difference of not. If you have no difference, you have perfect word, but I think it's not exist. If you have some possibility to improve, you use this to target the best way to improve the situation. And by this way, we propose two survey, one in US that was finalized, and one other survey that was ongoing for stingle bees in Latin America. For the hierarchization, prioritization of honeybees disease in France, we related by this advice of the ANSES, and you have the link if you need more information. But what is the method and the step forward? It's based of multi-criteria decision analysis. You have a first list of different diseases that was included in the exercise. And in this case, you have a lot of disease that was present in France, but also 3 additional exotic diseases that have a threat. You divide 6 domains of criteria that was considered: dissemination potential, economic impact, societal impact, impact of ecosystem, limitation of the effectiveness of control measure, and impact of the control measure. And each domain was scored by a scale from 0, not important, to 10, highly important, and the uncertainty was taken into account also: 1 for low uncertainty, 2 for medium, and 3 for high uncertainty. And after that, we weighting all of the domain, and you have an overall ponderate score by disease. And is it possible to rank the disease? Of course. And for the data, you show the advice. And the result is there. It's relatively the same that was presented previously. You have, for example, the 2 main important of the 3. It's varroa, Penicillium larvae, and the virus DWV, the deworming vine virus. And you have in the last column the degree of uncertainty. You have no very important uncertainty for the first, but in the middle, sometimes you have uncertainty, but it's not very important. The most important in terms of action is to beginning with the first. And you have the same in the exotic disease like Echina tremida. Of course, it's a main threat currently. For the second proposal, it's to beginning with the monitoring. And here we have a risk and protective indicator of beekeeping management practice for a country. What is the different step? You consider, of course, the beekeeping management practice. We discuss with the beekeeper. You find also, and you go back to the colony to verify if you have of not losses, and you discuss, and you perform an uni and a multivariate logistic regression analysis to target the most important element to improve. Or another technique is the classification tree analysis. But by this way, you have a beekeeping profile, you have an inventory of the bee management practice, you have identified the risk factor. If you have identified some risk factor, you essay to diminish this risk factor, the presence of this risk factor in for the beekeepers. And the reverse, if you have identified some protective factor, you essay to increase this. Of course, is interesting because it's inversely related to the mortality. And you have some recommendation, and you use new practical tools. It's in smartphone, you have directly some indication in real time. You have the same for pesticide. I name an example of pesticide in beeswax because beeswax is an intrant in a lot of for the beekeeping practice. And we use the same methodology. you have monitoring about all of the country that was randomized. You target, for example, brood comb wax, recycled comb wax, honeycomb wax, and capping wax. If you check in the right above, you find that capping wax, it's less number of pesticides present in the box plot. And it's interesting because you essay to improve the use of this capping wax, at least of in place, for example, of recycled combs. And you find, you show the different pesticide that was present, and we develop a toxicity risk by the risk quotient in real time, because beekeepers perhaps have a report of analysis, but not understand this in a true, it's a self word. And we need to help this by, for example, the bee-tox wax. Thus, we have a constellation of tools, and we develop two tools in real time. The real-time risk quotient is a calculator for pesticide, and a real-time beekeeping practice evaluator. It's free, completely free. It's in English, French, but is it possible to translate this in several languages? It's not a problem. And you have, for example, this. You have the possibility to have a new inventory of your practice, of you have this inventory before, and just to update, and you not integrate all of the things each fold. Is it possible? It's simply to organize this. And for the bee-tox wax, is the same. It's completely free. It's very used around the world. And you have in real time the wax toxicity calculator tools in your hand. You have a code of color, depending of the dangerosity of the toxicity of the different pesticide. You integrate in below, we integrate the different observation by the way of the report of the assay, and we use a risk quotient. Each pesticide residue concentration is divided by the lethal dose of 5T, when available, of course, and it is improved version. We use this, in this case, the frequency of occurrence of each pesticide, and currently we only have an additive effect, but we work about some synergic effect. And you have this risk quotient that depend of topical route of oral route for the bees, for example, and you have several target value that was used to go further in terms of recommendation. And you generate, just this is a show of the information. You put on generate a PDF, you have directly the PDF with calculation of the risk quotient, advice about the use of beeswax, for which use, and some recommendation. The third one is another thing. It's more related to the previous presentation. It's related to elicitation of experts, and you have the same. You have the true reality by observation or by survey. You relate this by an expert elicitation, and you essay to obtain the best way to work. And I propose the three different important message. The first one in the left is the fact that you have a general management index in x-axis, and you find that is the general index increase, you have less mortality, winter loss, because the winter loss is in y-axis. This it's very interesting because you have a proof of concept. If you have good management practice, you have less losses. Of course, you have other possibility to have loss, but if you target the beekeeping practice, you have some interest to improve the practice, to diminish the losses. Another thing is the middle. You have the rank of the different management measure that was an effect about the losses. And the third one is in the right. It's interesting because you have the log of the p-value of the different criteria, and you have the criteria in x-axis, and you find that you have a very interesting about around 20 and 30. You have this amount of criteria seems to be sufficient to discriminate the bee management practice around the different beekeepers. Thus, we optimize the number of criteria to be checked, because it is not possible to check 100 criteria in one fold, but it's an optimization of the number of the criteria should be monitored to improve the situation step by step. And what is the conclusion and the perspective? The proposed framework is useful and you have the proof of concept, but you need to evolve as the word. And I think we need to evolve in different area direction. The first one, it's a One Health approach, but you have, for example, human, the residues beeswax, you be able with this to essay to obtain what is the risk for human. And the same for honeybees, of course, is the middle. And also not forget the fact that you need to promote an eco-responsive apiculture for the protection of the environment. And you have also new hazard. New hazard, it's related, for example, adulterant, because if you talk about the beeswax, you have commercialized beeswax, and sometimes you have adulteration of this beeswax, and you have relation by the mortality. With the triangle, you find that you have a palmitin adulteration in beeswax in %, and you have the survival rate in the y-axis, and you find that if you have a certain amount of % of palmitin adulteration, you increase drastically the mortality. This is a proof of concept also. Of course, in Europe, but also in other continents, you have some international bodies that was interested and concerned by this, like EFSA. You find the risk assessment of beeswax adulteration, a recent advice. But also you have you need to be innovative, and the short communication that was presented there is completely innovative. It's a Bayesian topic model, and by this way you track all of the media in all of the languages. It's not a problem, and you track some element that presume some adulteration of and related to the trade. It's very a proactive activity, and I think it's interesting to manage also innovative way to work for the future and to propose some new tools for the beekeepers to protect them. And if I resume above, you need, of course, some brainstorming, some networking, and I like very well this initiative of this webinar. And you find also the complexity of the process, but also the interconnection. And we need for structuration, it's, I think, the role of the international body, but we need also to have some vision, strategy, step by step, that was proposed before. And below, it's my conclusion perspective. In the center, you have beekeepers and honeybees, of course, and colony, and you need guidelines. It's very important to have guidelines, beekeepers education and training, stakeholder engagement. I think it's very important to engage stakeholder, decision policy maker engagement, because without this engagement, you have no progress, scientific supporting advice based on the weight of evidence, combination of life and social science, because social science is interesting to find, for example, the determinants of the fact that you have an action by the beekeeper or not. It's very interesting. Further engagement, exchange network, interdisciplinarity approach, and very important because it's related to action, it's to manage and to propose operational tools that was completely free and available for all of the beekeepers. And for the final phase of my presentation is just the past, the present, and the future. The past is more related to honeybee medicine. The present is the One Health approach that was proposed just before by the previous presenter. But for the future, we need to consider, of course, the One Health and to increase really the One Health approach in the practice, but also not forget the eco-health, because you have different ecosystem, and also the planetary health. And the example of adulteration like this, or the disease and the trade, it's very related to this. If you need to increase the situation by, for example, by the beeswax that was commercialized, we need to have more planetary health in your head to secure the different movement. And finally, maintaining the health of the bee require, essentially, it's a key home message, good training, theoretical but also practical, scientific origin of information based of weight evidence, action, guidance and tools, collaborative works, and a normative framework to be created of reinforced, like, for example, adulteration. And the bees take care of us by supporting beekeeping education and scientific research. Here is just the different funder of my research and different monitoring, and thanks for this funder. And as an academic, I support, of course, some initiative of PhD students. And currently we move, because we have beekeeping practice in Belgium, in US, but we move also in Latin America for stingle bees. If you have interest, it is in Spanish and Portuguese to fit with the people that was in this area. Please complete the survey of this PhD student to help this PhD student to give more information about the best practice for stingle bees. Thank you very much.
Thank you very much, Claude. Okay, considering we are short in time, I suggest if you have questions, just to write them in the question and answer space or in the chat, and we will forward the question to Claude. He will answer in the next days. So please, let's go ahead with the presentation of Dr. Lotus Mohair. She is from the FAO country office in Oman and has a background in social research, public policy, and management. She brings her experiences in learning and working around the world in Australia, France, the UK, the United States, Belgium, and the UAE to her efforts across the various programs at FAO, including the project on apiculture that she will now present. So please, Lotus, the floor is yours. Thank you.
Thank you so much. The screen is clear? It's all right?
Perfect. Thank you. Even the voice. Thank you.
All right. Hello, everyone. Good morning, good afternoon, good evening. I'd like to thank the organizers for the opportunity to be here to showcase some of the efforts in the Sultanate of Oman in strengthening SMEs' capacities for sustainable and economic apiculture. So just some background about apiculture in the Sultanate of Oman. Beekeeping is a very old profession that has always been a constant source of decent income for many rural families, and Omanis have been practicing beekeeping since the 17th century. They used to harvest honey at high altitudes in mountains and oases, and in many Omani communities, bee products are used in traditional medicine and are an integral part of traditional healthcare in Oman. And therefore, honey is always present on the Omani food table. And Omani honey is reputed as one of the highest quality honeys in the world. In Oman, there are 3 types of bees. There's the local domestic bee, Apis mellifera geminatica, and this represents 83% of the honeybees in Oman. The second type are wild bees, known in Oman as butwiq, and they make up around 13% of the bee population. And finally, Carniolan hybrid bee, and this makes up about 4% of the bee population. There are also different types of honey in the Sultanate of Oman. A couple of the most famous ones are the sidr and the sumr. The sidr, the season usually extends from September to November. The sumr is usually in the summer from June to July. There's the luban, which is in the south of Oman, where the frankincense trees are spread, and this is produced in April. There's also the al-atam, which has won international awards at the 43rd Conference of Apimondia. Other types of Omani honey include shu'a and the flower honey. Of course, nowadays there are many challenges facing the sector, and this affects the growth of apiculture businesses and also the livelihoods of the rural communities who traditionally produce honey. Some of these challenges are related to harsh climatic conditions in certain regions in the country. Beekeepers are scattered, so there's a need to enhance organizational capacities at the national level. There's a need to improve technical knowledge and techniques to improve production and productivity. There's a need to enhance the production of value-added products and the capacities of beekeepers in producing value-added products. Now, the project, first of all, what makes it a unique experience in Oman is that it's a strategic partnership between the public sector, the private sector, and an international organization. So the project has 4 partners: the FAO, who is implementing, the Ministry of Agriculture, Fisheries, and Water Resources, the Public Authority for SME Development, and also the private sector in the OMIFCO, the Omani India Fertilizer Company. The project has aims to have an impact on the contribution of the apiculture sector to food security in Oman, and collective action in unlocking the potential of apiculture for improving Omani livelihoods. The expected outcome of the project is that apiculture value chain in Oman is strengthened and diversified. Now, the project is kind of piloted in the Dakhiliya and Sharqiya regions in the country, and it is hoped that upon conclusion of the project, it will be upscaled to other governorates in the country. There are a set number of beneficiaries for this project, 20 beekeepers, 20 commercial apiaries, 20 low-income families who will be trained. We call them the beginner beekeepers, who will be trained and will be given beehives in order to generate income for their families, private and public laboratories, honey shops, honeybee supplies, and many other stakeholders such as other ministries, producer organizations, etc. The project is based on 6 pillars. The overall aim is to enhance and diversify the beekeeping sector through strengthening national capacities around the honey value chain. And the 6 pillars are, firstly, enhancing organizational capacities of beekeepers through developing collective action. Second, to enhance the technical capacities of national institutions in bee health and sanitary control. Thirdly, developing the capacities of beekeepers in producing apiculture value-added products. Fourthly, developing the technical capacities of beekeepers in good apiculture practices, marketing skills, and quality control. Fifth is developing a certification program in order to improve the branding of Omani honey. And finally, working on knowledge and practices being documented and outreach products being developed to really have the benefit go beyond just the target group of this project. So thinking a little bit about the organizational capacities of beekeepers, the project is developing their organizational capacities. As mentioned before, this is one of the challenges because they're quite scattered along the country due to the absence of cooperatives. The good news here is that they actually do work together and exchange knowledge through social media platforms. So the spirit of collective action is really there, and the project is simply building on this existing strength. Trainings were provided around leadership, governance, improving collective action, building a common vision. And here I'd like to share with you a very interesting initiative from the Ministry of Agriculture, Fisheries and Water Resources, the picture on the left. They have a collective apiary in the Dakhiliya region, and it's a haven for beekeepers and hobbyists to exchange, to train themselves, and to be able to utilize this space. We had an assessment of the current situation and gaps of the laboratories in the Sultanate of Oman, and it was found that the public laboratories need to strengthen their capacities in bee disease and diagnosis to be able to support the beekeepers and be a reliable point of reference for them. The private labs, on the other hand, it was found that they are extremely well equipped and they actually are able to address the needs of the beekeepers. However, an interesting finding was that in this assessment, was that there is a need to increase the demand for the private labs. So the beekeepers are not utilizing these services that are available for them. And this could be addressed through changes in legislation, having different requirements in place from the ministry, or increasing awareness among the beekeepers themselves. And of course, we will be also providing equipment based on the assessment for disease diagnosis. So after having different types of assessments on the needs of the beekeepers in different fields, we found that there were gaps in the management of apiaries, and good apiculture practices and biosecurity measures were some of the things that the beekeepers needed training on. And we addressed those gaps through a capacity development program and some trainings that included developing the capacity to produce honey value-added products. Another challenge, as described by the beekeepers themselves, was marketing. So the key concern here is that they struggle with both standards, knowing them, meeting them, and the technical capacities in marketing. So the project is addressing this aspect based on international best practices, as well as meeting the requirements of the local, regional, and international consumer. For example, this is done through exploring the direction of the branding of Omani honey, having an action plan, in a participatory way with beekeepers and relevant stakeholders, supporting the development of a marketing network, looking into contract farming. And the project is also exploring the characterization of Omani honey and looking at the establishment as well of Omani national standards for honey, as at the moment Oman is following the Gulf Standards GSO. And therefore this project explores this important component, which, having these national standards will allow the unique Omani honey to shine locally and regionally as well. Finally, knowledge and practice documentation will be improved and outreach products will be developed through this project, through having an electronic platform linking beekeepers, research centers, and academic institutions. So it was found that the link between these stakeholders is not as strong as it should be. And so they're not able to utilize from the scientific research. So therefore, this platform will allow them all to come together, and it will be an easy exchange of knowledge. There will be study tours for beekeepers, enhancing international beekeeping cooperation. The project is in the process of producing a reference manual in Arabic, and this will allow the learnings generated from these activities to be of use for a wide range of beekeepers in the region, and videos and awareness communication material as well. And this is some photos from the annual honey market and honey exhibition in the Sultanate of Oman. Thank you for your attention.
Thank you very much, Lotus. This interesting project, very wide. So are there questions, Marco? Okay. So thank you, Lotus. Let's proceed. And we have now the presentation provided by Professor David de Jong. So David de Jong is Professor of Genetics, University of Sao Paulo, Brazil. He's specialist on Africanized honeybee, bee pathology and nutrition, and on propolis for human and bee health. Please, David, the floor is yours.
Thank you. I will begin presentation. You can see my screen now.
I cannot see it.
Okay, I have to go back. Criterion.
Okay, now something
Yeah, something's happening. Okay, let me try to.
Okay.
Can you see it now?
Yes, thank you.
Okay, try to.
In presentation, right? Yeah, go. Thank you.
Yeah, okay, I need to get rid of this. All right, so I work at the University of São Paulo, actually a medical school, but there's some history there. Warwick Kerr, who was famous for introducing African bees into Brazil, he was the first chairman of a genetics department in a medical school in Brazil. And as he worked with bees, we have a tradition of bee research in the University of São Paulo, especially in the town that I live in, Ribeirão Preto. This is a picture of a typical Africanized colony, obviously a strong colony, lots of brood and so on, and it shows that these bees can develop very strong colonies and also produce honey. So now let me see. Yeah, I'm trying to move my slides. For some reason, not doing that. Okay, here we are. So we have these current threats to the Africanized honeybee. So I've put down the ones that at the moment are concerned for us. One is there has been a fever to try to bring back European bees. And I saw this when I first got to Brazil in 1980. There were also some effort, oh, let's save beekeeping by bringing in European bees. But it turned out to be kind of on one side a mistake because it didn't really help. And the other side, it was some people who were trying to make money off the beekeepers by saying, oh, these bees are better and so on. Well, I'll get into more details there. The other problem we're concerned about is imported bee products that could bring in disease organisms like AFB spores and so on. And then there's some also illegal commerce of chemical controls for apiculture. We don't have anything really approved for use on bee colonies because we don't really need to treat our colonies. But then people, especially in some of the southern states, then products are brought in from Argentina and sometimes from Uruguay, and then they try to convince the beekeepers that they need them, and that can be a problem. And then I put the last on the list, pesticides, which sort of haven't been talked about very much in this meeting, but they are a big deal, and probably that's what mostly the biggest problems for killing bees and affecting beekeeping in Brazil. Well, let's go on from there. So I talk about importation of European queens, European honeybee queens. So see, people are trying to promote a better bee. And as I said, this is ill-advised because it doesn't really work. For instance, if you try to keep a pure European colony in Brazil, we have this experience in our own apiaries at the university, they just don't thrive. The Africanized bees are much better adapted to the Brazilian environment, and you have to baby them along. Now, you can produce virgin queens from these pure European queens and then open mate them, and they kind of work, but still they're not as well adapted as Africanized bees. So basically, the European honeybees are not well adapted to most of the Brazilian climates, and we can see this by comparing them side by side. And there are parts of Brazil where beekeeping hardly existed at all until the African bees came in. Now, we call them Africanized bees because they're kind of a hybrid between the bees that were already here, which are various European races. But in the end, since the African genes provide good adaptation to the situation in Brazil, then genetically we found that these bees that we have now are and have been having for the last more than 30 years, they're 85 to 90% genetically African, Apis mellifera scutellata. So when we are able to keep, and sometimes experimentally, and some beekeepers try to do it, where they'll keep European bees in their colonies, and then they find they're more susceptible. We have good data on that. They're more susceptible to varroa. Well, the small hive beetles, we don't have a lot of data. We have the beetles now for some years, but they don't really affect the Africanized colonies. At least we don't see any damage. You can find the beetles. It's kind of hard to find them, but they don't really seem to cause any damage. And the European honeybees, they're more susceptible to brood and adult diseases. For instance, Acarapus affects much more the European bees. We have good data on that, and the brood diseases too. Now, when people try to keep European bees, they end up really, what they're doing is they're keeping open-mated European queens in their colonies, so they have like a halfway hybrid between Africanized bees and European bees. And it kind of works okay for a while, but then what they notice is during our winter, which is not much of a winter, but colonies tend not to be able to forage as much, or there is much food available in the environment. Then those European colonies go downhill and they get weak and they get sick, and the Africanized bees do not. So beekeepers, as they learn to handle Africanized bees, they discovered that on their own. So, well, one of the problems why I'm mentioning the European bees is there's some consequences. So they know the people that are trying to introduce European stock, and again, I will emphasize they're really using open-mated European colonies, because otherwise the bees won't even survive. Then they find more disease problems, more problems with varroa and so on. And so they start using chemical controls, and that just makes the whole thing worse. Now, I'll give you a little bit more of my own background. I was a bee inspector in New York State from 1970 to about 78. And one of the things that I remember from that experience was that one of the worst things you can do if you want to control American foulbrood is use antibiotics, because we could eliminate our American foulbrood by carefully looking for it and eliminating disease colonies, but that never worked when the beekeeper was using antibiotics. He would just keep the disease going by hiding it. Well, here, this line I put at the end, they're Africanized honeybees, they do not need pest or disease controls. We can keep them without any kind of chemicals, which is what I think most people would like to, beekeepers would like to have throughout the world, and we have that. So that's something we don't want to lose, and what we try to do is understand how the bees can do that and the best way to protect them and not get in their way. So this situation with European honeybees, which is kind of a cyclical thing, this was in the late 1970s, early 1980s it happened, and then people realized that they were not going the right way, and they were getting fooled by people trying to make money selling these queens and special hives for the European bees. And then they sort of forget historically that this happened before and they start doing it again. So we need to do a better job of getting the story out. But the people who are selling these queens are taking advantage of ignorance by the people they sell queens to. Some of them may be well-intentioned, often they are not, but this new bee will not save beekeeping. And so again, they're selling open-mated Africanized or European queens that are open-mated with Africanized drones. Now, one of the misconceptions that people have had about Africanized bees, so here we have a comb of an Africanized colony, and here from a European colony. Now, so some of the early research was done, researchers like to use small colonies, 5 comb colonies in nukes, because it's easier to handle them. Well, if you do that with European bees, they will be storing honey and pollen and so on. In Africanized colony, in these nukes, you'll just see brood, and then people came to the conclusion that Africanized bees don't produce honey. But you don't produce honey in nuke colonies, you produce them in big colonies. So Africanized bees, they have a strategy of increasing or growing very fast. And then as the colony gets larger and larger, and when there's a good honey flow, they will produce honey, but not in a small 5-frame colony. So again, European honeybees, they get sick more easily, and then we can see that with European foul brood, with varroa and chalk brood. We have chalk brood now more than 10 years, and it's hard to find it actually. This is sort of a picture trying to show the difference between the Africanized bees and European bees, but there's a lot of variation in both. You know, there are European bees that aren't this yellow, and Africanized bees can vary a bit too. Africanized bees tend to be a little bit smaller. So could we replace the Africanized bee? Well, it's not possible. There are too many colonies around. They're too well adapted, and again, they don't. The European bees can't compete with them. Also, it's not an advantage because the Africanized bees are better adapted to these pests. And when they first arrived, as people learned to handle them, they realized they were producing a lot more honey than they were with the European bees, and honey production went way up. Now, if we wanted to, and that's an interesting point, we could select Africanized bees for characteristics that people may value, such as reduced defensive behavior. Now, actually, we did that, or one of the professors that I worked with at the Nielsen Spencer Suarez, he developed an Africanized bee that couldn't sting. And the beekeepers actually objected to that because they wanted their bees to be able to protect themselves. So I don't know that that's going to be a big deal, but it's something we could think about because there is quite a bit of variation in Africanized bees. We could produce a less defensive bee, let's say. Now, the reason we handle, when you don't know how to handle Africanized bees, they're pretty defensive. It's hard to handle. But as you learn to work with them, you learn to use the smoke. I say work without gloves because then you really learn to handle the bees, because if they sting you, you know you're not doing it right. You try not to provoke the bees, and that's a big mistake people make, that if you handle the bees like a bear by really protecting yourselves and not taking care of the bees, are going to really be very defensive. Then there's some changes you can make in the apiary. We like to use individual hive stands. Africanized bees swarm a lot, but you have to control that. They're very fast and efficient bees, and so you have to get ahead of them, not behind them, if you want to take advantage of their productive capacities. So in the end, once you learn how to work with these bees, they can be very easy to manage. I work them with just a regular veil and no gloves, and I don't have a problem with that unless somebody else is helping me who makes it, maybe he handles them so roughly that they start stinging everybody. Now, another point, the department that I work in the late 70s and early 80s, they actually provided virgin European queens to the beekeepers because the beekeepers were having trouble handling the Africanized bees. They didn't know what to do with them. And probably that was a good way to get used to Africanized bees. It was sort of a halfway bee. But after a while, they realized, well, okay, now we know how to handle what they realized they could handle the Africanized bees, and they were better bees than these European hybrids. So after a few years, there was no more demand for these virgin European queens. Even if they got them for free, they'd throw them away. Because, and they learned to work with the Africanized bees, and they found them better honey producers. And so, especially during our mild winters, you can really tell the difference between how the bees handle these diseases. So now, one of the other problems, besides ruining the genetics of the bees, by introducing European queens, is you're introducing new diseases. And it seems like every place, I worked for FAO as a consultant for a while in various countries, and every place I went, people were trying to introduce queens from another area, saying, oh, the reason our bees aren't doing well because we need queens for somewhere else. But what they're usually doing is bringing in queens that are not adapted to their local climate or environment, and then bringing in new diseases. And so I'm sure we got IAPV, Israeli acute paralysis virus, by bringing in queens from somewhere else. Nosema ceranae probably also, and other diseases, etc. So these introduced bees and the chemical controls that people try to use to keep them alive just makes it worse, and it interferes. Now, our bees are good at resisting diseases. When varroa first arrived in Brazil, we found sometimes 60 mites per 100 bees in adult bees, and we thought, oh, the bees will all die or something. They didn't. They had, gradually the infestation rates went down. I never in 42 years in Brazil, never saw a colony die of varroa. So that's an interesting point. So again, I say that beekeepers don't need the European honeybees. So I mentioned the importation of bee products. I have actually seen pollen, imported pollen with chalkroot mummies, dead larvae with chalkroot in bags of imported pollen, and then the person who imports them said, "Oh, we've got this powder. Nobody will buy the powder," so they started feeding that to the bees, and then chalkroot showed up. The viruses, we find this imported jelly, royal jelly, and so that's not good. And then AFB spores in honey, so we try to monitor that and require inspection for that. Then there's this idea of using chemicals that really they don't need them, but some people think, like, oh, if I apply an acaricide to the colony, I find mites on the bottom, varroa mites, and that means the bees are sick or something. But really, the bees handle the mites fine, and they don't need this kind of chemical control. But if somebody says, oh, you need it, and then try it, and they see the mites, and then they want to buy more, and that just makes the whole thing worse. So, as I mentioned, unfortunately, one of our major problems with the bees is still pesticides. And it's an interesting point that they stopped burning sugarcane, which was supposed to be good for the environment, but then burning the sugarcane actually killed a lot of the pests, so they end up using a lot more pesticide now, and that kills more bees. So at the moment, if someone were going to ask me what kills the most bees in Brazil, it's pesticides. Now, it's not just killing them, it's driving the beekeepers to areas where they don't have agriculture. So where you need the bees for pollination, suddenly you don't have enough bees. So for instance, citrus, even soybeans and coffee would be helped more if they would have more bees. So another small point is sometimes people will use pesticides to eliminate most, let's say a colony is in a tree or a building and they're stinging people, oh, let's put in some pesticide in it. And sometimes they'll kill all the colonies within a couple of kilometers, which is not good either. So then we have these huge areas for sugarcane, which is not good for the bees. And so this is supposed to be a green crop, but we could question that because there's no natural food sources or habitat for any bees, and plus they're using a lot of pesticides. And we have small hive beetles, but not a big problem at all, as I mentioned, but of course it's a concern we're looking at. So some of this, I think one of our most important solutions to reduce pesticides, that agriculture has to have a better idea of how valuable the bees are. And if we do that, and we even have an Uber of the bees, if somebody wants to know about that, they can write me. So thank you for your attention. I'll try not to go over too much of my time. So if somebody wants to contact me through the organizers, or here's my email. Thank you.
Thank you, David. Very interesting. This invincible bee. It's incredible. I saw a question about how is the method these bees are resistant. Marco?
Yeah, so if you're asking why the bees are resistant, there are a lot of things involved. And so one of the things we can see certainly is hygienic behavior. They're very good at finding varroa, even in brood cells. They'll encap the brood cells and look for varroa. They're good groomers. When we compare them with European bees, and we've done that, we put the mites on the bees, and then we can see that they attack them. The mites, and so there are a lot of factors involved. And see, beekeepers have tried to select bees for resistance by looking at specific factors. I think the bees are better at it themselves. So that's another topic. But how can bees become resistant? So I mentioned at the beginning we had very high infestations. Sometimes 60 mice per 100 bees, which is just absurd.
Okay.
In Europe and the US, the bees would die, I'm sure. And with us, that didn't happen. In fact, the infestation rates cycled down. So there are a lot of factors involved there. And basically, we didn't get in the way of the bees and just watch them do it. And now we have been working on how to understand how they did it.
Mm-hmm. Great. Thank you very much, David. So again, if you have questions, just write down the questions that we are not able today to ask. We will send to the speakers and they will answer in the next days, okay? Thank you very much. Okay, so let's go ahead with next presentation of Dr. Ping-Li Dai. Professor Ping-Li Dai is Professor Chief Scientist of Bee Disease Department of the Institute of Apicultural Research of the Chinese Academy of Apicultural Science, CAS, and Secretary General of the Bee Disease and Protection Committee of the Apicultural Science Association of China, ASAC. Please, Dr. Ping-Li Dai, are you there? Professor? This presentation, Marco, are you sharing it or Professor Ping-Li Dai share it?
Can you hear me?
Okay, perfect. Very good, Professor. Please go ahead. Thank you very much.
Okay, thank you, Giovanni. And I'm Ping Dai from Institute of Apicultural Research, CIS in China. And it's my pleasure. Today I will talk about biosecurity measures for Apicerana in China. And there is more than 4 million Apicerana colonies in China. The majority of colonies are located in mountainous areas, and beekeeping includes both traditional and modern methods. Pest prevention.
Professor, if you can you share in full screen if it is possible, so it's possible to see larger. Sorry for disturbing you. Probably, yeah, exactly. Perfect, thank you. Probably Yeah, it takes some time.
It's okay? No.
Probably it needs some time. Okay. No, I think you did well. It takes some time, probably. You can go ahead with the presentation. Thank you.
Oh, sorry. This one? It's okay now.
Yes, we can see the PowerPoint.
It's okay?
Oh, perfect. Thank you very much, Professor.
Yes, thank you, thank you. Okay. Okay, I will introduce the for part 3 main pests of Apimondia as the control principles and main pest control measures and examples of biosecurity measures for Apimondia in China. First, I will introduce main pests of Apimondia and their control principles. Apimondia main pests include 2 diseases, CSBV and EFB, and 2 insects, the great wax moth and the wasp. Usually, the pest management principles are prevention first and RPM. In my opinion, the prevention and control principles of Apimondia as follows 3 points. The prevention is important, including keeping apiary clean and prohibiting random introduction of queens or colonies and the screen for disease-resistant colonies. The strengthened colony management is important. The changing queens once or twice a year, use new comb every year, and leaving enough honey for bees. If the treatment is required, I suggest using environment-friendly controls, such as avoiding chemicals, isolating unhealthy colonies, and physical or biological control. Okay, I'll talk about control measures of May pests. The Chinese sackbrood disease is the most serious viruses disease of Apimondia in China. The pathogen is Chinese sackbrood viruses, CSBV. And the typical symptom, for example, the raising its head towards the top of the cell. The main transmission is infected larvae and contaminated bee bread. And the CSBV can transmit in colony by feeding noses and spread between the colonies by foraging, feeding, and robber bees, and so on. How to prevent and control CSBV? I'll list 5 points. The first one, keeping the colony warm in early spring and late autumn, and to ensure adequate food, especially pollen. The second way is disinfection. Strengthen quarantine, such as infected colonies are prohibited from moving to other areas, and the apiary should not randomly introduce queens and colonies. And fourth, choose disease-resistant colonies. And finally, early diagnosis and early isolation. Rapid diagnosis of CSBV in apiary, and followed by isolation of the infected colony and placed 1 to 2 kilometers away from the apiary. We have developed a product of rapid diagnosis kits of CSBV, and it can detect the CSBV in infected larvae within 5 minutes. The European furboard disease is the most serious bacterial disease of Apicerana in China. The pathogen can survive for many years in infested larvae carcass and remains virulent in pollen and honey. EFB may affect unsealed brood, and EFB can transmit in hive by cleaning or feeding behavior, and spread between colonies by robber bees and exchanging combs. Some prevention and control measures of EFB are similar with those used to combat CSBV, such as ensure adequate food for bees, disinfection, and quarantine. With the symptoms, the beekeeper can inspect EFB early. Accurate identification of EFB, like PCR detection, the samples can be sent to the professional laboratory to test it. I suggest graded management, such as isolating the suspect colony, changing queen and combs, and using Chinese herbs in the slightly infested colony. It's necessary to burn severely infected colonies. I'll list some of the most common Chinese herbs to be effective against the EFB. For example, honeysuckle. And 50 grams of the Chinese herbs are boiled and mixed to the 1 kilogram syrup. Then the slightly infested colonies are fed with the above syrup. The great wax moth is the most widespread pest of Apicerana in China. The wax moth eggs, larvae, pupae, adults are shown in these figures. Worker colonies will be seriously damaged by the great wax moth, and the great moth's newly hatched larvae feed on wax chips from the bottom of the hive. Then the larvae invade the comb from silk linking tunnels in the comb and feed along tunnels. The mature larvae pupae at the bottom corner of the hive or at the gap of comb. There are 3 generally control measures. According to the biological characteristics of the great wax moth, hardening is important for prevention. Regularly removing the residue wax chips from the hive and keeping the colony sanitation and clean up the old combs. The stored combs can be destroyed by the great wax moth, so the stored combs can be controlled by freezing or fumigation with the glacial acetic acid. I think biological control may be a better option than other measures because of its effectiveness and safety. We have carried out the lab and the colony experiments of Bacillus thuringiensis against the wax moth. It's the effect of spraying the comb with BT at lab after 4 weeks. This is negative control and those are Bt groups. And this is effect of spring on the comp with Bt against the great wax moth in hive, the negative control and this Bt treatment. We designed the trap based on the habits that newly hatched larvae feed on wax chips from the bottom of the hive. And the trap box with Bt containing wax can effectively prevent the great wax moth in colony for months. And the specific steps are listed. Prepare the bed. Secondly, spray the control solution on bed. Thirdly, evaporate excess water and assemble. And finally, place the assembled trap box at the bottom of the hive. Now, wasp is the most serious pest of Apimondia in mountain areas in summer. I list some of the most common wasps which are harmful to honeybees. And there are 3 measures to control wasps. If the beekeepers find a wasp nest, then they should ask the professional to destroy the nest. This is dangerous. So personal protection is essential in this situation. And in order to prevent wasps attacking from the entrance of the hive, installing hive entrance protection may be the good choice. Trapping is an effective method if many wasps threaten the colonies. This device is simple. They prepare a container, a slightly larger mouse for wasps to enter. The depth is about 10 to 15 centimeters. Then mix honey to water 3 to 1. The depth of the honey in bottle is about 1 centimeter. Then a wasp is placed in the bottle. Then place the bottle near the hive infested with wasps. Then replace or treatment once a day. Part 3, I will give some examples of biosecurity measures for Apimondia in China. The project from the China Agriculture and Rural Ministry support national pest surveillance of Apimondia. That establishing monitoring point. The main areas of Apimondia in China, then testing samples once a month and providing the control suggestion to beekeepers. And second, research and application of green control measures for pests of Apimondia, such as rapid diagnosis of CSBV, control EFB with Chinese herbs, and biological control of the great wax moth with Bt trap, and entrapment against wasps. The rapid diagnosis kits of CSBV has been used in 10 provinces, the main areas of Apimondia in China. And the prevention and control EFB with Chinese herbs is being used in Hubei province and Beijing. This is the feed Chinese herbs in a colony. And the prevention of the great wax moth with the hive support in Shanxi province, and the Hubei province. BT trap can control the great wax moth in 12 provinces. Entrap and high and have interest protection against wasps in Jiangxi province. This is entrapment of wasps. And third, technical training on biosecurity measures. For example, bee quality training for animal health supervision officers in all over country and the Heilongjiang province. And this training biosecurity measures will pass to beekeepers in China. Here I thank our team contribution to this work: Dr. Qin Yundiao, Wang Qiang, Yun Jun, Wu Yanyan, Gao Jing, Dr. Zhao Li, and Dr. Fen Liu, and my master students Han Bo, Wu Tong, and Yang Sa. And thank you for attention during a short time. So if you have any question, please contact with me by my email. It's my email. Okay, thank you.
Thank you very much, Professor Ping Li Doi. Okay, there only one question, yes or not. Is this virus CSBV the same of Apis mellifera or is different?
The same,
Is the same or not?
And the is the same.
Ah, it's the same. Okay.
Yeah, the CSBV is same, but the CSBV is more serious in Apis cerana, but in Apis mellifera maybe SBV, maybe not CSBV.
Okay.
Thank you.
Giovanni, you're muted.
Okay, sorry. Okay. Have you listened something about Marco when I started again since the beginning?
Yes, please.
Thank you. So let me present Dr. Cristiano Meneses. So Cristiano Meneses is an entomologist from Brazil. His expertise is stingless bees, biology, and management. He is also involved in public policies for bee conservation and sustainable growth of meliponiculture in this industry. Please, Doctor, proceed with your presentation. Thank you very much.
Thank you, Giovanni, and thank you the organizers for inviting me for this talk. I'm learning a lot today, and I hope now to share a little bit about our experience with the stingless bees.
Thank you.
Can you see my presentation?
Perfectly.
Okay. So the idea is to give an overview about the stingless beekeeping in Brazil and the biosecurity measures that we are taking to guarantee their protection and their conservation, mainly to keep the sustainable industry of meliponiculture. So we have many species in Brazil. We know about 250 different species, which represents almost half of the species known around the globe. And our challenge here is actually to decide which species to keep. So we have around 60 different species that are being managed out of these 250. So for these species, we don't need to go to the field anymore to capture hives from the wild. We can split nests, produce new colonies. And although many people say they don't produce much honey, that's actually not true. They are social bees, and some species produce a lot of honey. Of course, it's completely different. The size of the colonies, the size of the bees, there is a huge variation in the flavor, in the colors, and the difference between the honeybee honey and stingless bee honey is very big. The main difference is the amount of water. So stingless bee honey has more water content than honeybee honey, and there are unique biochemical process going on when they are producing these honey. So each one will produce a different and specific kind of honey. There are species that produce sour honey, others sweet honey, and some even salty honey with smells like cheese. So we have a great variety, and the price in the market is generally 10 times higher than the honeybee honey. But they are also being used for many other purposes. For example, crop pollination, like strawberry, acai berry, coffee. There are many different crops around Brazil that can be benefited by management of stingless bees. Around 30 different crops we have already tested and seen benefits of these bees. And because they are stingless, many farmers are open to receive them in their areas. And for the smaller species, it's much easier than honeybees because it's easier to focus in the crop that you want to pollinate. So there are many benefits comparing to the honeybees. They are also being used for environmental education because they are stingless. Children can get close to them, see their society, understand their products and their importance. And based on the bees, they can understand the whole of conservation, the whole of nature, and why we should conserve it. So it's been very, very successful in this area as well. And another big boom that is coming in Brazil nowadays is the people who are keeping bees in their houses or apartments as hobby, just as a pet. So this guy that you are seeing in the slide, for example, in the center of São Paulo at the 15th floor, he's keeping about 50 hives in his balcony. And because they are stingless, you can keep them even together with your children. So this is becoming very popular in Brazil. They are being advertised even in big TV programs. And so many people are interested in stingless beekeeping nowadays because of that. And this is a possibility for keep in touch with the nature and having this kind of animal at your home, and even, who knows, produce your own honey at home. And because of all these possibilities, stingless beekeeping is becoming actually a big industry in Brazil nowadays. Many people are focusing in splitting the nest, producing new hives, and selling them to all these people that want them at their home or that want them to start their business. So this is becoming actually a big business. And as all big business, we start to see many problems that were not coming before. I'll list the 5 most relevant threats to the stingless bees here, and we'll go through each one. But my idea is to show what we are doing to deal with each of these problems. So chemical pesticides, deforestation, diseases and pests, climate change, and movement of colonies are the main threats nowadays to stingless bees in Brazil. Of course, chemical pesticides are very relevant, and what I can say about this related to stingless bees is that the different species that we have also different susceptibilities to these pesticides. So the same chemical may affect one species and not affect others, and the risk assessment that we do nowadays with honeybees do not protect the stingless bees. So we have many different species. Each one have different susceptibilities. So what we are doing is developing specific risk assessments for the different groups of stingless bees in Brazil. We had a big change in the last years related to this issue. IBAMA, that is the organization from the government who takes care of the pesticides regulation, are reevaluating the neonics and fipronil, the most important chemicals that are affecting bees. So this is going on. We already have the report for one of the products with restrictions for specific applications and also restriction for specific crops. But also in many cases, they are also asking the chemical companies to provide more information to take decision about these products. Besides this, we have also a big program nowadays to stimulate biological control of pests. So this is an area that is increasing a lot. And the last data I saw, Brazil is nowadays the first in the world in terms of area covered with biological control. And this is a big industry nowadays that increases about 20% per year in Brazil. So we have now big companies selling macroorganisms, microorganisms, many different solutions to pests. So this is an important way that is also being used in Brazil. We have some specific issues that we are facing with stingless bees. So this is what you are seeing in this video is a stingless bee larva that eats a fungus to survive. If they don't eat the fungus, they die. So they have a symbiosis system. And what we found is that this is not a single fungus. Actually, it is a mixture of many different fungus that together make a microbiome that is important for the larva nutrition. So what we found is that they provide a kind of specific kind of steroid that the larva must eat to survive. And what we are seeing in many species that is these relationships with microorganisms are essential for their survival. So we are very concerned about the use of fungicides. This is a paper not very recent, but made in US, where they saw that the most relevant chemical that is coming inside the hives are fungicides, not neonics, not fipronil, not other chemicals, but fungicides are the most relevant. And before, we were not very concerned about this because fungicides do not kill bees in general, but they may affect their microbiomes, and these can actually affect their health. So this is an important issue that we are working nowadays. A lot of information is coming from research, very new research that will help to develop public policies in the future. The second point that I want to talk is deforestation. And this is a huge problem in Brazil nowadays. We were in a good pathway a few years ago, but in the last years, we are increasing again the area that is being deforested in Brazil. And for you to have an idea about the numbers that this deforestation represents, in the last year, we lost about 1,320,000 hives of stingless bees from these areas that was devastated. So this is huge, and this is the minimum estimation considering one colony per hectare, and in some areas we have even more than that. So this is a big problem that we are facing nowadays, and we don't have a good public policy nowadays for this. We hope to change the government in the next year to change this scenario. Another key issue that is very recent, and we don't have many experts in Brazil working with this, is the problems with diseases and pests of stingless bees. We already know that some honeybee diseases like the European full brood can affect stingless bees, and many stingless beekeepers use honeybee materials for their management, like pollen to feed them, or honey, or even wax to strengthen the colonies. And this can be an important route of disease for stingless bees. We also have some specific diseases of stingless bees that can be spread with them. So when you move a colony, you also move the local disease like this forage fly that attacks specifically these species, and it may be in equilibrium in one place with a certain species. When it's taken away, it can become a serious problem for other species that are not adapted to them. So moving the colonies around is also a problem, and most of these diseases are still not well known. We already have recorded dozens of diseases from pests, insects, and also bacteria, virus, and many diseases from stingless bees that can become a serious problems in the future. So this is an issue that we must address. So far, what we have is in São Paulo state, in the southeast of Brazil, we have some regulations and assistance to beekeepers who lose colonies that can send samples, and the specialists will look exactly what happened, and they're trying to understand and map where are these diseases and which one are the most relevant to deal with. So this is the step where we are now. We are also working with climate change a lot. There are many good scientists in Brazil studying this. And in this case, for example, that you are seeing the slide is the prospection of the area that the Melipona subnitida, a species that is from northeast Brazil, will be able to survive in the future with the climate change. So this is key information to help to take decisions where we should preserve, where we should start national parks, and how will we deal with the change that will happen in the scenario. So by predicting these areas, we can take decisions based on the scientific knowledge. The problem nowadays is because most of decisions are not considering the information that we have been producing in science. So what we can say about this is that we must do a bigger effort to transform the information that we have in science in a language that the policymakers can understand and take decisions. And as I said before, in my opinion, this is the worst scenario for stingless bees, is the movement of colonies across regions. So many beekeepers, stingless beekeepers, are bringing hives from Amazonia to other regions just because they want to have the exotic species and bees that are not from their region. So this is becoming a big thing, and people pay a lot of money for, let's say, foreign species that are not from their own region. So this is becoming a big business, but illegal. It's not allowed. We have some restrictions that do not allow people to do this, but we are already seeing some problems. For example, this species is from north of Brazil, from Amazonia region, and they were taken to the southeast of Brazil and are spreading in nature and becoming a big problem for the local beekeepers. So these species are competing with the local ones, and some people are reporting colony losses because of this competition. We have some restrictions already to avoid this, but because we don't have much fiscalization, people are still doing this kind of movement and becoming a problem. What we did recently, we mapped the most relevant species and their distributions, and we are actually teaching people about the importance of not moving the bees, of keeping their own bees that we have all around Brazil, but choosing the ones that are at exactly that place, on their place. So education is being the most important tool, most important measure in this case. Just to say very quickly, in Malaysia, this is becoming a big problem because they are having problems to keep their colonies in manageable hives. So most people are cutting the trunks and producing honey from these trunks. So in Malaysia, this is an example of an unsustainability in stingless beekeeping that we must be aware to avoid supporting this kind of activity. We see that meliponiculture, the stingless beekeeping, has a great future ahead, but we must work really hard to spread good information to people, to teach beekeepers about all these issues that I mentioned. And actually, we are spending a lot of effort in this direction. I myself became a kind of YouTuber in Brazil because we were seeing a lot of wrong information at the internet, and many new beekeepers going to the wrong way because they were listening to this wrong information. So as a scientist, we should think better about how we communicate our results, how we communicate our knowledge to people. And these videos in the YouTube is one fantastic way to help to avoid all these problems. I thank you for the attention, and I will be very happy to answer any questions.
Thank you, Cristiano, for this very interesting presentation. Are there questions for Cristiano?
Yes, there is one question. For movement of colonies, do you use some scenario analysis as supporting information for decision making?
We have very little information from the field. One point is because before it was too bureaucratic for registering your own hives. So what we are doing nowadays is facilitating the registrations and developing less bureaucratic systems. So this is at the very beginning stage. So we don't have still a map of where the beekeepers are, their size, but this is being developed at the moment. It's a big step to start any public policy. Before that, it was all informal.
Very good. So thank you again, Cristiano. Thank you very much.
Thank you.
So let's proceed with the last presentation of Dr. Delphine Pansiera. Delphine is a biologist and beekeeper. Since 2020, she works at Wageningen University and research in the Netherlands, and is head of the Dutch National Reference Laboratory for Bee Disease. So Delphine, please. Hello, welcome,
Yes,
and the floor is yours.
Can you hear me?
Yes, very well.
Okay, wonderful. So, okay, let me see if I can share my screen. I haven't practiced that. Yes, that should work. You see it?
Yes.
Okay, then
Yes.
I will put it.
Presentation, good. Thank you very much.
That's a bit slow. Okay, now it's working. So first I'd like to thank Giovanni and the organizers for inviting me. It's very nice. It's been very interesting and informative for me today. Lots of different topics around bee health. So I'll try to be brief because I know I'm the last talk, so please don't fall asleep. Listen to me. I'm gonna I'm gonna tell you about bumblebees and the biosecurity measures around their commercial use. So first, you probably all know that, but just to be clear, what we call bumblebees are bees from the genus Bombus, which are about 250 species worldwide. 45 of them are cuckoo bumblebees or parasites, social parasites. And the rest of them are pollinators, and they're primitively eusocial. So they have an annual cycle. Only the young queens, the mated queens, survive the winter and start a new colony in spring. Of course, that's only true for temperate regions, because you see from the map that they are also present in tropical areas. So I put a few photographs just so you see the diversity in shape, size, and colors. It's quite nice. Bumblebees are known as pollinators for a very long time. And the earliest example we have of this is in the end of the 19th century, in 1885, and then in 1906 again. British people collected lots of queens from different species in order to ship them to New Zealand to pollinate red clover, because They colonized New Zealand, put clover there and to feed the sheep, but of course they had many problems with pollination because there was no pollinating species with a long tongue that could pollinate it. So they imported bumblebees, and some of them established there, and that's from the same populations that they introduced them later on, Bombus ruderatus in Chile. And that is why I took the example of Bombus terrestris that people from Europe must know very well because it's a very common species. The original native range of Bombus terrestris is what you see here with the different subspecies. So it's restricted, let's say, to Europe, the Mediterranean and Middle East area. But what you see in the map on top here on the right side in red, that's the actual current distribution. So this was the native area, and now it is, well, basically everywhere. So that's the kind of things that can happen when you start introducing species for pollination or other things. But now about its commercial use. Well, in 1985, almost by coincidence, at least that's what I read in the articles, some Dutch people discovered that it's more efficient to have bees pollinating tomato plants than people shaking them, because before that date in the Netherlands, all the greenhouse tomatoes were pollinated by hand. So they were using sort of vibrating equipment. So the plant is shaken and then the pollen detaches, and that cost 10,000 euros per hectare per year of greenhouse. So you can imagine it's quite expensive. That is why as soon as bumblebee rearing was available, it was not so efficient. So it was a bit expensive in the first years, but it was still cheaper than hand pollination. That is why the first company, Biobest, which is based in Belgium, started in 1987. In the year after, Coppert, which is a Dutch company specialized in biological control, started also rearing bumblebees. You can see in the graph here that within the first 5 years of commercial use, well, all the Dutch tomato growers switched to bumblebees instead of hand pollination, which is probably a very smart move from there. And at the time, only Bombus terrestris was produced, but then as the American market was started, those companies also started to produce other species such as Bombus impatiens, occidentalis. Now for Japan, they produce Bombus ignites, and for the Asian countries, they produce Bombus lucorum. What you see here is Bombus terrestris or lucorum, because it's actually not possible to differentiate them morphologically. And that's Bombus impatiens. Also here, that's a colony of Bombus impatiens. Oh yeah, I've put a little video so you see how it looks like when they are in their nest, all nice and fluffy. It's a bit like honeybees in a way, but of course it looks a bit more chaotic, and they also store honey in pots like this. So just like any bees, really. Okay, I need to move. Yeah. Okay. The last estimate of the volume of colonies produced and traded around the world is only from 2004. I could not find fresher information. I contacted the companies but got no response, so I'm sorry, you'll have to do with some old numbers. But it was already in 2004 1 million colonies per year that were produced commercially and traded around the world. And the two companies I mentioned before, they are still the leaders on the market. There are a few more, but these two companies produce the vast majority of this 1 million of colonies. So the colonies are kept in those plastic box with ventilation, and they're shipped like that with the cardboard around. And when they arrive at the growers, you just need to open here, and the bees come out by one of the holes and come in by the other. So it's very practical. They are used mainly for indoor pollination for greenhouses. You see here tomatoes, and you see here strawberries, but sometimes they're also used outdoors for pumpkin pollination and this sort of thing. But the vast majority of the colonies are sold for greenhouse pollination, though. Now, I'll go to the animal health law and the biosecurity measures why we're here today. So, as it was mentioned at the very beginning of the webinar, bumblebees are mentioned in the animal health law, and it is very clear about what type of colonies can be moved around and sold, and it's only colonies that are bred, reared, and packaged under environmentally controlled conditions. So if you have a bumblebee colony in your garden, you want to send it to your friend in another country, well, that is not possible. Don't do it. It's forbidden. And oops, sorry. What's very important is that those establishments have very strict control and check that they don't have small hive beetle infestations. That's actually the most important part of the animal health law for bumblebees. So, okay, they are a bit more specific things, but I'm not going to read the law text. You can do it yourself if you want. But the important points are every colony that is dispatched must go a visual examination for the small hive beetle, but also any kind of symptom. Any colony that doesn't look good should not be sent away. Yes, again, small hive beetle, that's actually the most important that comes up in the law text all the time. Colonies should be a maximum of 200 adult bumblebees, so to keep them small, to avoid parasites that you don't see. And another very important point is that every packaging material should be destroyed, and the container in which the colony is can be kept, of course, as long as the colony is alive, and then should be destroyed. It should not be reused for something else to avoid parasite transmission. So I found in the library here a nice book about bumblebee parasites and bumblebee, let's say, problems. And given the cover, it looks like humans can be actually one of the biggest problems of bumblebees. But I'll tell you a bit about parasites today. So bumblebees have, of course, internal parasites. Nosema bombi is specific to bumblebees, but it's very similar to the disease in honeybees. It creates diarrhea, basically. So the symptoms are very obvious, and it's quite easy to spot these colonies, and they are destroyed at the rearing facilities to avoid spreading. You also have different types of parasites, such as nematodes. This is actually a quite prevalent one in nature, Spherularia bombi. It's a nematode that infects the ovaries of queens. What you see here in the picture is an ovary with all the nematodes in. And one of the results is that the behavior of the queens change a bit, but the main problem is that they could become sterile. So you can imagine for commercial rearing, that is not good. And those queens get killed automatically because they cannot form the colony and so on. So this is actually a parasite that is very well controlled for in the rearing facilities. There's other parasites such as internal mites, Locustacarus bruckneri, that's a tracheal mite. And that used to be a problem in the 90s in the rearing facilities, but now it is very well controlled for. At least we don't find it anymore. For the last 10 years or so, we have had no positive sample. So they have really improved on controlling this. You can see here, yeah, that's the mite. It's very small and it stays in the trachea of the bumblebee. You also have a lot of commensal mites. So they're not parasites per se. They don't really feed on the bee, but they're, let's say, hitchhikers, and they eat things from the nest. But of course, when you have very, very high infections, like you see here, then it is a burden for the bumblebee. And this is also something that is avoided in rearing facilities. I think they just destroy colonies that have too many of them, but that's also something we don't see when we receive samples. So that's, yeah, something you see in nature, but it's not so much of a problem in commercial rearing. What can be more of a problem is the parasitic wasps, such as this species, Melitobia. So they are like parasitic wasp. They go in the nest, lay eggs, the eggs hatch, and then the larvae feed from the brood of bumblebees. So that, of course, can kill colonies and is also something they control for in the rearing facilities. And one other aspect important here with regards of what we talked about before is that there are actually all the notifiable honeybee parasites are also checked for when they export bumblebees, because theoretically Tropilelaps, varroa are not parasites of bumblebees. I don't think I've seen papers showing they can reproduce in the brood and so on, but they may quite well travel with them. So it's important to check for that when colonies of bumblebees are being shipped. And that's something they do look at, varroa and Tropilelaps. And of course, the small hive beetle. This is all very strict about the small hive beetle. And also other types of brood diseases, American fall brood, chalk brood. Again, I have not had positive samples of that, but that is any brood that is not healthy, they will eliminate the colonies at the facilities anyways. So that's for the practices of the industry at the moment, what they do check for in their facilities. And I will just briefly tell you about what they do not check for and might maybe be a problem already or in the future. But let's say internal parasites such as Cryptidia, we know that they are found in bombers. They are found in higher numbers in commercial bombers, and we know that the spillover is something that also can happen. So that might be of importance in the future. And of course, all the viruses. It is true also of honeybees. There's no virus in the list of notifiable diseases of bees, but of course, we know they're very closely related to varroa. For some of them, they might be actually the reason why we see such high mortality when you have high varroa infestation. So that might be something that becomes more important to look at in the future. Yeah, and I show here the result of a study made in Canada, where they sampled bumblebees near greenhouse facilities where you have introduced bumblebees, and you see that in black it is Cryptidia bombi. The levels are very high, while it is virtually absent in the sites further from the facilities. So I don't know many studies of that type, but that's, I think, quite interesting. So just to summarize, I think I'm running a bit late, sorry about that. We have two main species of bumblebees that are used worldwide for pollination, Bombus terrestris, Bombus impatiens in the American continent. More than 1 million colonies are traded each year. So they're produced in big facilities and shipped all around the world. So the risk is there. It's quite important that they are checked thoroughly. Several specialized parasites of bumblebees are looked at in the facilities, but they're not actually in the list of notifiable disease. But of course, all the honeybee parasites are in the list of notifiable disease, and that's what the veterinarian authorities have to look for in priority. The production facilities are regularly checked by the authorities, and also random samples are checked for internal parasites that you might not see if there's no apparent symptoms. So that's the situation now. And in the perspective, well, viruses, Cryptidia, are not present in the monitored parasites, but we do know that there's a high potential for spillover. So maybe that is something we should collectively think about in the future. So thank you very much for your attention. And that's it for me. So if you have questions, well, feel free to ask. I don't know if I should stop sharing my screen.
Thank you very much, Delphine.
Yeah.
Are there questions, Marco?
There is only one question. I don't know if it is too long to be answered, because the question is, how can I breed and multiply Bambus terrestris after we buy it? Only to pollinate, it means, not for trade.
Yeah. Well, so bumblebee rearing has a long history, actually, in the Netherlands, but everywhere. And I think that a lot of the protocols for rearing bumblebees are available. I think the difficult points are the mating and then the queen hibernation. That's where there's a big bottleneck. But I think if you are interested, you can find this quite easily in the literature. Yeah. All right.
Thank you very much, Delphine.
Thanks.
Thank you. Okay, so we are perfectly on time, and let's go toward the conclusions. So today it seems we are doing the first steps toward the knowledge on the risks for the bees' health and management at the global level, isn't it? And I want to thank, first of all, Francois in insisting with me to enlarge the number of the talks on the different topics on the bee world and their health. So it seems that a lot is known, but a lot still must be investigated, especially for the diseases, the diagnosis, and even for the awareness on the chemical risks like pesticides or the destruction of the ecosystems. Moreover, it seems even that a lot of natural remedies like the Chinese herbs that we heard before still need to be further investigated. So indeed, we today, I think, experimented the presence and the talks from different international organizations like the World Organization for Animal Health, the Food and Agriculture Organization of the United Nations, and the International Federation of Beekeepers Association, Apimondia. We are very honored of that, and I thank them all once again for participating. It seems now a good moment to start thinking on the constitution of an international working group on good beekeeping practices and biosecurity measures in apiculture. This working group could foresee the active involvement of the Food and Agriculture Organization of the United Nations, FAO, the International Federation of Beekeepers Association, Apimondia, and the World Organization for Animal Health. Of course, if they agree. The working group could collect experts from all over the world and will provide recommendations on good beekeeping practices and biosecurity measures in beekeeping with a very wide approach at the global level on all the bees. Finally, the working group could provide guidelines, general principles on the basis of the SDGs, the Sustainable Development Goals, the sustainability principles, the responsible use of the veterinary medicines in apiculture, and the One Health approach. So now I would like to leave the floor to Jeff Pettis and to the other international organizations that I have just named to listen by them what they think about this hypothesis and if they think it could be something that we could further discuss in other tables, like, I don't know, Istanbul in the Apimondia Congress or in September at the kickoff meeting of the BeeDeNet projects. Please, Jeff.
Okay. Thank you, Giovanni. And thank you to all the speakers for the session today. It was very good. Of course, we at Apimondia would support anything that promotes beekeeping and also with the challenges that we face that helps to bring us to healthier bees. So I think we should, as a different groups come together. We already have a memorandum of understanding with FAO in Rome, and we're able to work on many things with them. But reaching out to OIE and to your institute, I think, yeah, I would welcome you to Istanbul, and we can look at having a session, either a larger session that's open to maybe all, or just at least we have time to come together as smaller individuals and discuss it in Istanbul. We have plenty of time there. I don't know, actually Fanny is one of the people in charge of the program, so I don't know as far as fitting something officially into the program. We're developing that right now, but certainly we are open to further discussion and would be glad to partner with the groups that have been proposed. Yep.
Annie, do you want to add something else?
Is Fanny on?
Yes,
yeah.
It works. I was trying to unmute myself. Thank you. Well, thank you, Jeff, for passing me the flow. Yes, indeed. We already have reserved some space in the program. I don't know exactly which day, what time yet, for a roundtable specifically for this proposal. I think it's a great opportunity and idea to use this time that a lot of scientists, a lot also of beekeepers will be there, and representatives from the World Organization for the Animal Health and FAO, and of course us from Apimondia, to sit together and not only discuss, but finally work to make it happen, to start working on this, to have common approaches and have something coming out that it will be even more, how to say, helpful and applicable by beekeepers in different regions of the world. So yeah, it just for us, it's only to decide how much time do we need. The rest, it's already on the way. Thank you.
Very good. Thank you very much. Thank you, Jeff. Thank you, Fanny. I want to ask if there are still present Francois, and if is still present Junxia. So even to have their opinion about this possibility. Thank you very much, Francois.
Yes, thank you, Giovanni. I would like to say that, so thank you, yes, for this very interesting presentation. We saw the need to promote responsible and prudent use of antimicrobials in beekeeping practices, the importance also of eco-responsible apiculture, and the need not to move species of bees from country to country and even from region to other region in the same country, and the need to work therefore with the local species. So all these to say that it's very important to have a good management practices for beekeepers, and therefore a working group will be very useful and very interesting. And so I'm totally in favor of this. After, of course, we need to discuss, we need to see how to build this working group. But yes, I think it's a good proposal. Thank you.
Thank you very much, Francois. And from FAO, I don't know if Junxia is still there, or
maybe I can mention something on behalf of FAO headquarters.
Thank you very much.
From FAO side, we will be also very happy to be involved in the discussion and support the creation of the working group for biosecurity measures and also sustainable beekeeping. While we are not clear from FAO headquarters to participate in the Apimondia Congress in Turkey this year, we can keep discuss about this proposal through different occasions as well. We want to be involved in this discussion further, and of course following our also procedures within FAO as well. Thank you very much.
Thank you very much, June. Yes, please consider even the possibility you could continue to discuss about this topic in the BDNet kickoff meeting that I hope it could be hosted in the FAO headquarters. So, in conclusion, I thank you all for participating to this webinar. The final goal was to stimulate new ideas and synergies to the advantage of the whole apiculture sector. And I hope we did it. I wish you all a nice weekend and see us in Istanbul then at the Apimondia Congress. And as they say here in Saudi Arabia, where I am now, inshallah. Goodbye, everybody. Thank you once again. Goodbye.
Thank you. Goodbye. Goodbye. Thank you.
Thank you all.